from plant to plant is called cross-pollination and helps different plants create fruit. More than 30% of the world's crops and 90% of wild plants need cross-pollination to survive. Many of the fruits, vegetables, and nuts we eat, such as almonds, apples, carrots, and avocados, need honeybees to cross-pollinate their flowers and help them grow. Farming bees. Many honeybees live in the wild, but some are raised on farms. Beekeepers, people who take care of bees, help honeybees make hives in movable wooden boxes. They keep the bees healthy and collect their honey and wax to sell. Beekeepers often keep their bees in orchards and near plants they want cross-pollinated. Beekeeping is a big business all over the world. In the United States alone, bees cross-pollinate more than $15 billion in crops per year. Honeybee honey also makes farmers more than $150 million per year. Many people are worried about honeybees disappearing because without cross-pollination, we might run low on food. Colony crisis. In 2006, beekeepers in the United States say something strange happened. Many of their honeybees suddenly left their hives and never came back. The bees appeared to be healthy before they left. Scientists called this strange disappearance colony collapse disorder. But what's causing it? Scientists think climate change may have changed the time of year some flowers bloom. They also think the loss of honeybee habitats and the use of pesticides that kill bees play a part. No one knows for sure what's causing the bees to leave, but honeybee populations may continue to drop every year. How to help? We now know that honeybees help us by cross-pollinating fruit, vegetables, and nuts. They also provide delicious honey they make on their own. Even though they may sting, honeybees play an important role in what we eat. Farmers and scientists are working hard to help save honeybees, and you can help too. Make sure the pesticides your family uses don't hurt honeybees, or don't use pesticides at all. You can also ask your family to keep honeybees around to help your own garden grow. The next time you see a honeybee outside, remember how important it is to your next meal.
We Need Spiders by Therese Shea. Our friends, the spiders? What do you do when you see a spider? Most people jump away, or at least back up slowly. Then they think about whether to kill the spider or place it far away from them. Did you ever think about just leaving the spider alone? Spiders are actually very useful to people. Of course, they don't know it, but just by living their lives, spiders help us. They eat insects, other arachnids, and small creatures, which helps keep some animal populations under control. Without spiders, we might be overrun by flies, mosquitoes, and other pests that are much more unpleasant to live with. But they're creepy. Perhaps so many people are afraid of spiders because of their appearance. They seem creepy because they look so different from creatures we think are cute and cuddly. Like other arachnids, spiders have 8 legs and a body divided into 2 parts, the abdomen, stomach, and the cephalothorax, head and torso. If that's not creepy enough, most spiders have 8 eyes placed in rows on their head. Some have 6 or fewer eyes, though. Strangely, even with all these eyes, most spiders don't have good eyesight. They have different ways of catching prey than using their sense of sight. What about venomous spiders? Many people are scared of spiders because of their venom or poison. However, very few species make venom that can harm people. The black widow, brown recluse, and Brazilian wandering spider are 3 spiders with venomous bites. Spider bites aren't usually deadly. Scientists think spider venom could have important uses in medicine. Scientists at the University at Buffalo are studying how the venom of the Chilean rose tarantula might be able to treat muscular dystrophy. People with muscular dystrophy have muscles that get weaker over time until they stop working. Venom may be the answer to helping these people live longer and healthier lives. Spiders worldwide. Some people think spiders are the most important insect predator, so it's a good thing they're found everywhere. Spiders are found on every continent in the world except Antarctica. Most live on land, but at least one species makes its home in water. Many spider species prefer tropical areas to cooler areas. However, some spiders are found high in the mountains where it's very cold. Tropical areas are home to many different kinds of bugs. We need spiders to eat these bugs, such as mosquitoes and flies, so their populations don't boom out of control. Smart hunters. Scientists divide spiders into groups based on their hunting methods, those that actively hunt and those that build webs. Hunting spiders have good eyesight that they use to spot their prey. Jumping spiders leap great distances right onto their prey. Web-building spiders usually don't see well. They build silk webs that trap prey and carry their vibrations to the spider. Orb weavers make a circular web that flying insects don't see until they're stuck in it. Bolas spiders let out one thread with a sticky drop at the end. They wait for prey to walk into it or even swing it at prey. Super strong silk. A spider lets out silk from body parts called spinnerets. It wraps its prey in silk, turning the prey as it works. Then the spider may carry the prey somewhere until it's ready to eat. Most spiders make more than one kind of silk in their abdomen. They have different uses for different silk, such as wrapping their eggs and making a nest. Spider silk is so strong that scientists are hoping it can be used someday to make bulletproof vests and strong ropes. Some companies are also trying to use it to make products such as shampoo and makeup. Spider snacks. Spiders play an important part in their ecosystem. Ecosystems require a balance between the amount of animals and plants that live together. Predators must eat their natural keep populations under control. Spiders help their ecosystems by eating many bugs and small animals. Some spiders are also food for other larger animals. Depending on the species of spider, its prey can include crickets, flies, bees, grasshoppers, moths, butterflies, and other spiders. Some spiders hunt bigger prey. Six-spotted fishing spiders can walk on water and catch and eat fish. Some spiders can even catch fish 5 times heavier than themselves. Send in the spiders. Some scientists think pests would eat much of the world's food supply if spiders weren't around to eat them. More than 600 species of spiders make their homes on U.S. farms. Spiders are such good predators that they've been taken to new locations to control insect populations there. They've been placed in apple orchards and rice fields to eat pests that ruin crops, such as grasshoppers. Many people think this is a better way to control pests than spraying crops with insecticides, some of which can harm people. Spiders are helpful for backyard gardens and inside your home, too. Help the spiders. Every time people cut down forests, clear fields, or change the natural world, they're threatening spider habitats. Some cave spiders, for example, are endangered or in danger of dying out. Their homes have been flooded or even destroyed by people for building purposes. Endangered spider species don't get as much attention as other species in danger. However, they're important too. Not only do spiders help people by eating pests, spiders are an important food source for other animals, such as birds, lizards, and wasps. Next time you want to squish a spider, remember all the good it does. Besides, it's scared of you too. A Look at Earth by Mary R. Dunn. The planet Earth. Earth is one of the 8 planets in our solar system. However, Earth is different from the other planets. It is the only planet known to have life. Plants, animals, and people live on Earth. Earth has living things because it is far enough from the sun to not get too many of the sun's rays. However, Earth is still close enough for the sun to warm it and keep it from becoming a land of ice. Earth has the gases that plants, animals, and people need, too. It even has water, which all living things need to live and grow. Orbiting the sun. Earth is the solar system's 3rd planet from the sun. Earth travels around the sun in an oval path called an orbit. It takes Earth 365 days, or 1 year, to finish its 595 million mile, 958 million kilometer orbit around the sun. All planets circle the sun in orbits. The closer a planet is to the sun, the faster the planet moves in its orbit. Earth travels at a speed of almost 19 miles per second, 31 kilometers per second. Scientists believe Earth's speed keeps it in its orbit. If the planet did not keep moving, it would be pulled into the sun. Earth's axis. Earth spins around an imaginary line through the middle of the planet. This line is called an axis. As Earth spins, one side of it faces the sun. It is daytime on that side. The other side of Earth is in darkness, and it is nighttime. It takes Earth 24 hours to make one full turn on its axis. Earth tilts on its axis. The part of Earth tilted toward the sun gets more of the sun's rays. This causes warmer weather. It is summer on that part of Earth. The part tilted away from the sun has winter and colder weather. Earth's atmosphere. At all times, Earth is covered by a blanket of air called the atmosphere. The atmosphere keeps some of the sun's unsafe rays from reaching Earth. It also keeps Earth safe from some of the meteors flying through space. The atmosphere burns most meteors up before they can crash into Earth. Two important gases, nitrogen and oxygen, are in the lower part of the atmosphere. Nitrogen helps plants grow. Oxygen is a gas animals and people need to breathe in order to live. Earth's gravity holds the atmosphere close to the planet so that the gases will not move away. Earth's oceans. Just as plants and animals need air, they also need water to live and grow. Earth is the one planet in our solar system that is mostly covered by water. In fact, nearly 3/4 of Earth is covered with water. Earth's water can be found in many bodies of water, such as rivers, lakes, and seas. The largest bodies of water are called oceans. Oceans store heat in the warm seasons and give off heat in the cold seasons. This helps keep Earth's temperature just right for living things. Inside Earth. Scientists study Earth's waters and atmosphere, but they also want to know what is deep inside Earth. To learn this, they study rocks that come out of volcanoes. They also have special tools to help them understand earthquakes. Scientists have learned that a ball of hard iron and nickel, called the inner core, is at Earth's center. Hot, melted iron, called magma, covers the core and makes up the outer or outside core. Thick rock, called the mantle, lies past the magma. Rocks and dirt cover the mantle and make up Earth's crust. Plants, animals, and people all live on Earth's crust. The moon. Some planets have many moons, but Earth has just one moon. You can see the moon almost every night in the sky. Earth's moon was formed over 4 billion years ago. The moon is about 1/4 of the size of Earth. Scientists have learned that the moon is cold and hard on the outside. They think its inside might be made of warm, melted matter. Just as Earth orbits the sun, the moon orbits Earth. As it orbits Earth, the moon's gravity pulls on Earth's axis. This pull helps cause tides in Earth's oceans. Astronauts on the moon. Since the 1960s, 12 astronauts have traveled to Earth's moon. They dressed in special spacesuits to help them breathe and move around. The astronauts walked in the moon's gray, dusty soil. They drove a small car called a lunar rover and visited rocky places called highlands. They found smooth lava flows called Maria. The astronauts brought more than 800 pounds, 363 kilograms of moon rock and soil back to Earth. Scientists tested the rocks and proved there has never been water on the moon. However, they found that, if they were watered, plants could grow in the moon's soil. A changing planet. At the same time that they are learning about the moon, scientists are studying our own Earth. Earth is always changing. Every day, pieces of Earth's crust move a tiny bit. Sometimes the pieces move quickly and cause earthquakes. Earthquakes break down landforms. Floods wash away landforms. Volcanoes spill out lava and make new land. People change Earth too. We dam rivers, reshape beaches, and flatten land. Some of the changes people make hurt Earth. For example, some machines we use make gases that destroy Earth's atmosphere. All people should take good care of Earth, though. It is our home. Cool facts. Earth is about 93 million miles, 150 million kilometers from the sun. The first living things on Earth were in the oceans. Earth is the only planet with just one moon. Because the moon has no atmosphere, the footprints of the astronauts who have visited the moon will stay there for millions of years.
A Look at Jupiter by Suzanne Slade. The largest planet. Jupiter is the biggest planet in our solar system. More than 1,300 Earths could fit inside this huge planet. On a clear night, You can search for Jupiter in the sky. Jupiter looks like a bright star. However, Jupiter does not burn as stars do. The sun's light makes Jupiter shine. Jupiter is the second brightest planet after Venus. People have noticed the bright light of Jupiter moving across the night sky for thousands of years. Over time, Jupiter has been known by many different names. Today we call the planet Jupiter, after Jupiter, the king of the Roman gods. Jupiter on the move. Jupiter is the fifth planet from the Sun. The 4 planets closest to the Sun are known as inner planets. Jupiter is the first of the 4 outer planets. Jupiter moves in an oval path around the Sun, called an orbit. It takes about 12 Earth years for Jupiter to travel once around the Sun. Jupiter also spins around a pretend line through its center, called an axis. Jupiter spins faster than any other planet. Jupiter makes one full turn in only 9 hours and 50 minutes. This length of time is 1 day on Jupiter. A gas giant. If you traveled to Jupiter, you would not need landing gear. This is because Jupiter is a gas planet. Gases are not hard enough to land on. Jupiter is mostly made of gases called hydrogen and helium. It has water in the form of gas, too. Gases also form Jupiter's atmosphere, a 600-mile, 966-kilometer deep cover of gases that sits on the planet. Fast-moving clouds in Jupiter's atmosphere make beautiful orange and white stripes. Warm gases traveling from inside Jupiter make white stripes, called zones. Cold gases moving toward Jupiter's center cause the belts, or darker stripes. Inside Jupiter, Jupiter's core or center is mostly made of different metals. It also has matter called silicon. No one is sure exactly what Jupiter's core is like. Some astronomers think that it is hard and rocky. Others believe the core is melted and is like a hot, thick soup. Jupiter's core is about 7,500 miles, 12,000 kilometers wide. This is about the same size as the planet Venus. Astronomers believe that Jupiter's huge core is between 36,000 and 50,000 degrees Fahrenheit, 20,000 and 28,000 degrees Celsius. This makes it even hotter than the outside of the Sun. Stormy weather. Jupiter's atmosphere is full of stormy and windy weather. Sometimes lightning flashes across its clouds. It has strong winds that can blow up to 400 miles per hour, 644 kilometers per hour. Spinning storms are also found in Jupiter's atmosphere. The largest storm on Jupiter is called the Great Red Spot. An astronomer named Robert Hooke discovered the Great Red Spot in 1664. The twisting winds of this storm continue to blow today. The size of the Great Red Spot often changes. Sometimes it is the size of Earth. Other days, it grows as large as 3 Earths. All around Jupiter. Jupiter has 3 rings that circle around it. These rings are mostly made of space dust. Moons also orbit Jupiter. Jupiter has more moons than any other planet. Astronomers have found 63 moons so far, and new ones are discovered all the time. Jupiter's smallest moon is about 1 mile, 1.6 kilometers wide. The largest is more than 3,000 miles, 4,828 kilometers wide. This means it is bigger than the planet Mercury. In 1610, Galileo Galilei discovered Jupiter's 4 largest moons. He made a tool with powerful lenses called a telescope to see them. These 4 moons are called the Galilean moons. Io and Europa. The Galilean moon closest to Jupiter is called Io. Io is a little larger than Earth's moon. There are at least 9 live volcanoes on Io. Every year, thousands of tons of lava stream from these volcanoes. The shape of Io changes as new lava continues to flow. The next Galilean moon, Europa, is 417,000 miles, 671,000 kilometers from Jupiter. Europa is covered with ice. This white and gray moon looks smooth and has many thin dark lines. Astronomers believe these lines were formed when water from inside Europa pushed through the ice that covers this moon. Ganymede and Callisto. Jupiter's 3rd Galilean moon is called Ganymede. It is the largest moon in the solar system. Ganymede is 3,280 miles, 5,279 kilometers wide. Astronomers think the outside of Ganymede is covered with rocks and ice. Ganymede has large, deep holes called craters. Craters form when big rocks crash into a planet or a moon. Callisto is the Galilean moon farthest from Jupiter. It is made of rock and ice. There are more craters on Callisto than on any other object in the solar system. Callisto is the darkest Galilean moon, but it is still 2 times brighter than Earth's moon. Traveling to Jupiter. Astronomers today learn about Jupiter from space flights. The first spacecraft to fly past Jupiter was Pioneer 10. It left Earth on March 2, 1972, and reached Jupiter 21 months later. Pioneer 10 took close-up pictures of Jupiter. In the following years, other spacecraft traveled to Jupiter and studied its storms, wind, and lightning. A spacecraft named Juno left for Jupiter in 2011. It studied Jupiter's atmosphere and core. In 2015, another spacecraft called Europa Geophysical Explorer searched for places to land on Europa. Someday, people may study Jupiter while living on one of its moons. Cool facts. Jupiter is so huge that all the other planets in our solar system could fit inside it. Most planets are round, but not Jupiter. It spins so fast that the middle of the planet becomes fat, and the top and bottom of the planet flatten out. Not all Jupiter's moons have names. Newly discovered moons are given a number. Later, scientists give a name to each moon. The spacecraft Pioneer 10 visited Jupiter. It carried messages and pictures of people and of Earth, in case it is found by beings from another planet.
A Look at Mars by Mary R. Dunn. The Red Planet. The planet Mars has always held much mystery. For example, people have long wondered about the planet's color. Even from Earth, Mars looks red. It is often called the Red Planet. Scientists now know that iron oxide, or rust, in its soil makes Mars red. However, long ago, Mars's red color made people think of blood and war. Therefore, they named the planet for Mars, the Roman god of war. Over the years, people have wondered if anybody lives on Mars. Many people have written stories about Martians or people from Mars who want to take over Earth. Mars's place in our solar system. Mars is the 4th planet from the Sun in our solar system. It is the last of the solar system's 4 terrestrial or Earth-like planets. The terrestrial planets are fairly small and rocky. The planets that lie past Mars are large and made mostly of gas. Mars travels around the Sun in an almost circular orbit or path. It takes Mars 687 days, or 1 Martian year, to travel around the Sun in its orbit. Earth's year is 365 days. That means a Martian year is almost twice as long as a year on Earth. Mars's land and atmosphere. Mars has 2 parts, the southern hemisphere and the northern hemisphere. The southern hemisphere has high landforms. It is old and rocky. The northern hemisphere has lower landforms. It has fewer craters or large bowl-shaped holes that form when big rocks crash into a planet. This makes scientists think the northern hemisphere formed later than the southern hemisphere. Mars's atmosphere is not good for living things. The air on Mars is filled with carbon dioxide, a gas that is unsafe for people and animals to breathe. Mars is also very cold. It is generally about -81 degrees Fahrenheit, -63 degrees Celsius there. Volcanoes. Mars has several very high mountains. Some of these mountains form a place called the Tharsis Ridge. The Tharsis Ridge is about 17 miles, 27 kilometers high. A volcano called Olympus Mons lies near the Tharsis Ridge. It is the largest volcano in the whole solar system. Olympus Mons is about 341 miles, 549 kilometers wide, and 14 miles, 22.5 kilometers high. Olympus Mons is an extinct volcano. Near Olympus Mons is a big cliff. Some scientists believe that, long ago, Mars had an ocean that wore away the rock and formed the cliff. Canyons and dunes. Along with volcanoes, Mars has giant canyons. The largest canyon, Valles Marineris, is about 1,864 miles, 3,000 kilometers long, and 372 miles, 600 kilometers wide. It is much bigger than Earth's Grand Canyon. Some scientists think floods of water formed Valles Marineris. Others believe the crust of Mars broke and formed the canyon. They think Mars's crust broke because the planet cooled after it formed. Mariner 9, a spacecraft that orbited Mars, found a field of sand dunes. Sand dunes are hills of sand that were piled up by the wind. The sand dunes on Mars are much like Earth's sand dunes. Water on Mars. Scientists have long looked for running water on Mars. In 2004, rovers landed on Mars. One rover found rocks that had minerals found only in water. The rover also took pictures of small rocks that scientists think could have been formed only by water coming out of the ground. Scientists named some of the stones after kinds of ice cream, like mud pie and cookies and cream. In 2006, scientists studied pictures of Mars that a spacecraft took in 1999, 2001, and 2005. The 2005 pictures showed new trails of matter that were almost certainly left by moving water. This means Mars sometimes has running water. Phobos. Mars has 2 moons. Some scientists think the moons are pieces of rock that were left over after Mars formed. Other scientists think the moons were objects that Mars drew into its orbit. One of Mars's moons is called Phobos. It is covered with craters like those on Earth's moon. It takes Phobos 7 hours and 39 minutes to orbit Mars. Phobos gets pulled about 6 feet, 2 meters, closer to Mars every 100 years. Millions of years from now, Phobos may get too close to Mars. If that happens, Phobos could be ripped apart or crash into the planet. Deimos. Mars's other moon is called Deimos. Deimos travels more slowly in its orbit than Phobos. It takes Deimos 30 hours, or 1¼ Martian days, to orbit Mars. Deimos looks smooth and black and is only about half the size of Phobos. Scientists think Deimos may be made of rock and ice. Like Phobos and Earth's moon, Deimos has craters. Its biggest crater is 1.4 miles, 2.3 kilometers across. Deimos looks like it has fewer craters than Phobos does. This is because many of Deimos' craters are filled with dust called regolith. Scouting trips to Mars. Scientists are planning scouting trips to Mars. They want to know if there was ever life there. If Mars once had living things, scientists want to know what made life on the planet die out. Scientists plan to send a spacecraft called Phoenix to Mars. Phoenix will dig into the icy parts of the planet to find out about the history of water on Mars. After that, NASA hopes to set up a lab rover on Mars. The lab rover will test the planet for the best places for spacecraft landings. Someday, people might at last visit the mysterious red planet. Cool facts. Mars has ice caps, or huge sheets of ice at its poles. These ice caps get smaller in summer, but grow again in winter. Mars has dust storms. The spacecraft Mariner 9 had to wait 1 month for a dust storm to stop to get a clear view of Mars. Scientists have found some dark sand dunes on Mars that are the shape of candy kisses. Mars's moons, Phobos and Deimos, are named for 2 of the sons of Ares, the Greek god of war. A Look at Venus by Mary R. Dunn. Earth's sister planet. The planet Venus is sometimes called Earth's twin or sister because it is about the same size as Earth. Venus also has many of the same landforms Earth has, such as mountains, plains, and valleys. In our solar system, Venus is the second planet from the Sun. Venus is the brightest planet in our solar system. During part of the year, Venus moves toward Earth. Throughout this time, you can see Venus glowing like a star in the night sky. The other part of the year, Venus moves away from Earth. Then Venus can often be seen in the morning sky. Venus's orbit. Venus travels around the Sun in a nearly circle-shaped path, called an orbit. It takes Venus 1 Venusian year, or 225 days, to orbit the Sun. A Venusian year is 140 days shorter than a year on Earth. Sometimes Venus passes between the Sun and Earth. This passing is called a transit. Long ago, scientists discovered that if they measured Venus's transit from many different places on Earth, they could figure out how far Earth is from the Sun. Scientists still use Venus's transits to study the planets. One of Venus's transits happened on June 6, 2012. Venus's axis. As Venus orbits the Sun, it spins in the opposite direction on its axis. An axis is a pretend line through a planet's center. The time it takes Venus to spin all the way around is 1 day on Venus. Venus spins so slowly that one day there lasts as long as 243 days on Earth. Venus's spinning makes the sun rise in the west and set in the east there. The opposite is true on Earth, where the sun rises in the east and sets in the west. Some scientists think Venus once spun as Earth does. They believe something big crashed into Venus and changed the way it spins on its axis. Looking at Venus. From Earth, Venus looks very bright because the sun's light makes it shine. However, scientists have trouble getting a close look at Venus, even with a telescope. This is because thick, spinning yellow clouds cover the planet. Venus's clouds are different from Earth's clouds. While Earth's clouds are mostly water, Venus's clouds are made of acid. Strong winds of up to 220 miles per hour, 354 kilometers per hour, push the clouds around Venus. Scientists study what Venus looks like below the clouds with spacecraft. The spacecraft send radio waves through the clouds and take pictures of Venus to send back to Earth. The air on Venus. From pictures taken by spacecraft, scientists also know that Venus is very hot. Venus's thick clouds trap the sun's heat. This is much like the greenhouse effect on Earth. It makes Venus very hot. The planet can be as hot as 870 degrees Fahrenheit, 466 degrees Celsius. Besides being very hot, Venus also has high atmospheric pressure. The atmospheric pressure on Venus pushes down about 90 times more strongly than it does on Earth. The pressure is so powerful that it would flatten a spacecraft in under a day if it landed on the surface of Venus. Landforms on Venus. Like Earth, Venus has mountains and volcanoes. Venus also has bowl-like forms called craters. Craters form when rocks crash into a planet. Venus has fewer craters than Mercury and Mars do. Scientists think this is because Venus's surface has changed more than that of other planets. They also think Venus's thick clouds might keep some of the rocks that fly by from reaching Venus. Landforms on Venus are named for important women. A deep valley is named for the Roman hunting goddess Diana. Another landform is named for Sacagawea, a Native American woman who guided the explorers Lewis and Clark. More landforms on Venus. Venus has some landforms that are not found on Earth. For example, Venus has big, round, crown-like shapes called coronae. Coronae can be more than 100 miles, 160 kilometers wide. Scientists think coronae formed when hot matter from inside the planet came to the surface. Venus also has raised places that look like hills and valleys that formed in different directions. These are called tesserae. Scientists think that the crust or outside of Venus may not be fully hard. They believe that the crust may be able to change shape and move around over time. Visiting Venus. Spacecraft have taught scientists a lot about Venus. In the 1960s, an American spacecraft named Mariner 2 traveled near Venus. It sent back pictures to Earth. It helped scientists discover that the planet is very hot and always has clouds around it. In the 1970s, the Russian spacecraft Venera took pictures of Venus. It looked for signs of water and measured how fast the wind blew. Magellan, another American spacecraft, orbited Venus in the 1990s. It helped scientists map Venus's surface. They even let the spacecraft crash land on Venus to find out more about the planet's thick clouds. Learning more about Venus. In 2005, scientists sent off a spacecraft called Venus Express to learn more about Earth's nearest neighbor. Venus Express began orbiting Venus in April 2006. It studied the planet's air, clouds, mountains, and craters. Scientists still want to know many more things about Venus. They want to find out if Venus ever had water. They want to see if the heat on Venus is the reason it is not more like Earth. Scientists believe that learning about Venus will help them understand Earth better too. Knowledge of Venus could even help us deal with the greenhouse effect on our planet. Cool facts. Venus is named for the Roman goddess of love and beauty. Venus has no moons or rings. Venus is the only planet that has pancake domes. These strange pancake-like landforms are miles across and miles high. A day on Venus lasts as long as 243 days on Earth. This is longer than it takes Venus to go around the Sun. Earth's orbit takes it nearer to Venus than to any other planet. Exploring Comets by Jennifer Way. What is a comet? Have you heard of Halley's Comet or the comet Hale-Bopp? They are two comets that have passed Earth in the last few years. Comets are pieces of rock, ice, and frozen gases that orbit or circle the Sun. Throughout history, people have recorded seeing comets. Around 300 years ago, astronomers discovered that comets return after a set number of years. Since that time, astronomers have learned much about comets. They believe that comets were formed around the same time as our solar system. The orbit of a comet. Comets travel in paths called orbits. These orbits are caused by the sun's gravity. The gravity of the planets a comet passes also helps shape its orbit. Comet orbits are highly elliptical. This means that the shapes of their orbits are long ovals. The size of a comet's orbit sets how long that comet takes to move around the sun. A comet's orbit can take as little as 3 years or as long as millions of years. We see comets only when their orbits cross near Earth's orbit. The nucleus. The nucleus is the only part of a comet that is always present. It can be thought of as a sort of dirty snowball. The nucleus is made up of small pieces of rock, ice, and frozen gases. Some of the frozen gases found in the nucleus are water vapor, carbon monoxide, and carbon dioxide. The core, or center of the nucleus, sometimes has a small rock around which the rest of the nucleus has frozen. The nucleus is the smallest part of a comet. The nucleus of a middle-sized comet is only about 6 miles, 10 kilometers across. The comma. The comma is a cloud of gas that circles the comet's nucleus. The comma is larger than the nucleus. It is most often about 62,137 miles, 100,000 kilometers around. The comma and the nucleus together make up the comet's head. The comma appears only when the comet nears the sun. As the sun warms the comet, the ice on the outside of the nucleus turns into gas. This is called sublimation. The gases glow and can be seen from Earth. As the gases continue to warm, the comma grows larger. The dust tail. Most comets have a yellowish dust tail. The dust tail forms as the solar wind pushes dust in the comma away from the rest of the comet. The dust tail bends because of the comet's elliptical orbit. When the tail first forms, it points toward the sun. As the comet gets closer to the sun, the solar wind gets stronger. It pushes the dust tail away from the sun. Sunlight shines back the dust, which can make it possible to see the tail from Earth. As the comet moves away from the sun, the dust tail begins to fade. The ion tail. A comet's ion tail is longer than its dust tail. An ion tail can be up to 100 million miles, 161 million kilometers long. The ion tail forms as the comet nears the sun. During sublimation, some of the ice becomes ionized. This means that when the ice turns to gas, some of that gas becomes charged. These charged gases are what cause the ion tail to glow blue. The solar wind pushes the ion tail away from the sun in a line. Like the dust tail, the ion tail begins to fade as it moves away from the sun. Short-period comets. Astronomers group comets based on how long their orbits take. Short-period comets have orbits of fewer than 200 years. Many astronomers believe that short-period comets come from the Kuiper belt. The Kuiper belt is a disc-shaped belt of matter beyond the orbit of the planet Neptune. Astronomers think it is filled with small, icy objects. They believe that the pull of gravity from nearby planets and crashes with other space matter cause comets to leave the Kuiper belt. They then begin their elliptical orbit around the sun. Long-period comets. Astronomers call comets whose orbits take longer than 200 years long-period comets. The comet Hale-Bopp is a long-period comet with an orbit of about 2,380 years. Some long-period comets have orbits that take 30 million years. Long-period comets are believed to come from the Oort cloud. This round cloud of matter lies far past the Kuiper belt. Astronomers believe the Oort cloud is made of dust and ice. They think that objects in the Oort cloud become comets when passing stars push them into our solar system. Studying comets. Astronomers study comets using telescopes. Telescopes are tools that let us see faraway things by magnifying them. Some telescopes are small enough to hold in your hand. Astronomers use large telescopes in buildings called observatories. These telescopes let them see into outer space. Space probes are another tool astronomers use to study comets. A space probe is a machine that is sent into space to take pictures and record facts. It allows astronomers to look more closely at comets than they can from Earth. Comets are cool. Comets do not last for all time. Most comets break up over time. Some comets crash into planets or the sun and are destroyed. Comets that crash into the sun are called sun grazers. Comets are among the oldest parts of our solar system. Astronomers believe comets are icy leftovers from the beginning of our solar system, more than 4 billion years ago. By studying comets, astronomers hope to learn more about how our planet and solar system began. Exploring the Sun by Rebecca Olian. A special star. You can see many stars when you look at the night sky. During the day, you can see just one star. This star is called the Sun. The Sun is a ball of gas that sends out light and heat. It is in the center of our solar system. 8 planets circle the Sun. The planets closest to the Sun get the most heat and light. Earth is the 3rd planet from the Sun. This is the reason that Earth gets enough light and heat for plants and animals to live. Without the Sun, there would be no life on Earth. Earth and the Sun. The Sun looks much larger than the other stars in the sky. This is because the Sun is the star closest to Earth. However, it is still very far away. The Sun is about 93 million miles, 150 million kilometers from Earth. If you drove a car through space at 70 miles per hour, 113 kilometers per hour, it would take 152 years to reach the Sun. The Sun is much bigger than Earth. Earth measures 7,926 miles, 12,756 kilometers across. The Sun is 865,000 miles, 1.4 million kilometers across. It would take more than 109 Earths lined up side by side to fit across the Sun. A ball of energy. The Sun is both very big and very hot. The temperature in the middle of the Sun is about 27 million degrees Fahrenheit, 15 million degrees Celsius. This heat causes hydrogen atoms to move so quickly that they crash together. When 2 hydrogen atoms crash into each other hard enough, they come together and form a helium atom. They also give off energy. Energy is the power to work or to act. The energy travels out into space in the form of heat and light. We feel the heat and see the light when it reaches Earth. The Sun's layers. The Sun has different layers, just as an onion does. The core is in the center of the Sun. It is where the Sun gets its energy. This energy moves from the core through 2 layers called the radiative zone and the convective zone. Next, the heat enters the Sun's photosphere. After energy leaves the photosphere, it moves through the Sun's atmosphere. The chromosphere is the atmosphere's inside layer. Its outside layer is the corona. The corona is very hot. It reaches about 2 million degrees Fahrenheit, 1.1 million degrees Celsius. Sunlight. Energy travels through the Sun's layers in waves. It can take these waves 1 million years to reach the Sun's outside layer. Outside the Sun, the waves travel in all directions. It takes light 8 minutes to travel from the Sun to Earth. The Sun shines on the half of Earth that is facing it. It is day on this part of Earth. It is night on the part of Earth that faces away from the Sun. As Earth turns, different parts of it face the Sun. Day becomes night on the parts of Earth that move away from the Sun. Solar eclipses. What if you were outside during the day and the sky suddenly turned as dark as it does at night? This can happen during a solar eclipse. A solar eclipse takes place when the moon passes in front of the Sun. Sometimes the moon blocks only part of the Sun. This is called a partial eclipse. A total eclipse happens when the Sun is totally hidden. A total eclipse can be seen somewhere on Earth about once every year and a half. Solar eclipses last only a short time. The longest total solar eclipse lasted just over 7 minutes. Stormy weather. The Sun causes the weather on Earth. Sunlight warms the water in oceans, lakes, and rivers. The warm water rises and forms clouds that carry rain and snow. This is called the water cycle. The Sun's warmth causes the water cycle. The Sun has storms much like Earth's, only without rain. The Sun's storms are made of very hot gas. Huge bands of gas the size of 10 Earths rise above the Sun. Particles, or tiny bits of matter, form a solar wind that blows out the Sun at more than 1 million miles per hour, 1.6 million kilometers per hour. How we learn about the Sun. People learn about the Sun by studying it with special tools. They take pictures of the Sun with solar telescopes. Telescopes are tools that make faraway objects look closer. People look at these pictures instead of looking at the Sun. You can hurt your eyes by looking directly at the Sun. Satellites are machines sent into space. Some satellites measure the sun's heat, light, and particles. One satellite found a sound like a beating drum coming from the sun. The sun thumps about once every 5 minutes. Running on sunshine. All life on Earth needs the sun. The sun gives light to plants. Plants use sunlight to make food using a method called photosynthesis. Some animals eat plants. Other animals eat those animals. Plants and animals form a food chain. Food is what gives living things energy. The sun also supplies solar energy, which makes some toys and tools work. Solar energy comes directly from the sun. A solar cell changes sunlight into energy. There are even some cars that run on sunlight. Shine on. Every day the sun sends out its energy. We feel its warmth on our skin. Our eyes can see because of its light. The sun's energy lets plants and animals live on Earth. As long as the sun shines, Earth will keep getting heat and light. However, no star can last for all time. The sun is about 5 billion years old. At the end of its life, it will grow so big it will swallow up Earth. We do not need to worry about this, though. The sun will keep shining for at least another 5 billion years.
Thunderstorms by Doreen Gonzalez. Thunder, lightning, rain is pouring down, and the hairs on your arms are standing up. Suddenly lightning shoots from the sky, and a loud crack cuts through the air. A thunderstorm has hit. A thunderstorm is a rainstorm with thunder and lightning. Lightning is a flash of electricity. Thunder is the noise that lightning makes when it flashes. Most thunderstorms last about 30 minutes. Severe thunderstorms, however, last much longer. A severe thunderstorm is one that brings hail, strong winds, or tornadoes. A severe thunderstorm can damage buildings and uproot plants as large as trees. It can even hurt people. The clouds above. Thunderstorms form when there is a lot of warm moisture or vapor in the air. The vapor rises and cools, forming puffy clouds called cumulus clouds. With enough moisture, cumulus clouds get bigger, and their tops grow into tall towers. At this point, they are known as cumulonimbus clouds. The air inside them moves upward, forming an updraft. At the same time, vapor inside the clouds turns into raindrops. As they fall, they create downward winds called downdrafts. Sometimes the cloud tops spread out to form anvil clouds. These are the kinds of clouds that can turn into a severe thunderstorm. Where in the world? Thunderstorms can happen almost anywhere. Some of the strongest thunderstorms happen in Argentina, Australia, Pakistan, and Bangladesh. Thunderstorms are common in the tropics. This is the area around the equator, where the air is wet and warm. In the United States, thunderstorms happen in every state. Florida has the most thunderstorms. Thunderstorms are least common on the West Coast and in Alaska and Hawaii. Severe thunderstorms are most common in the plains between southern Minnesota and Texas. Thunderstorms can form in any season. However, they are most common in the spring and summer. They usually happen in the afternoon and evening. Electric skies. Lightning forms when an electric charge builds up in storm clouds. Negatively charged particles build up at the bottom of the cloud. They are attracted to positively charged particles in the ground below. The particles stream toward each other, creating a flash of lightning. The heat from lightning explodes the air around it, making thunder. You see lightning the moment it happens. Sound travels more slowly than light, though. It takes about 5 seconds for sound to travel 1 mile, 2 kilometers. You can use the time gap between lightning and thunder to figure out how far away lightning is. Ice from the sky. Severe thunderstorms sometimes bring hail. Hail forms when an updraft pulls a raindrop high into the clouds, where cold temperatures freeze it. The frozen drop then falls. As it falls, it gets coated with more moisture. Another updraft may carry the drop back up and freeze the new coat of moisture. This can happen several times until the drop is heavy enough to fall to the ground. Hail can grow quite large. Large or small, it can cause a lot of damage. It can destroy plants, dent cars, and tear up roofs. Hail can also hurt people, and large hail has killed people. Water in a flash. Some thunderstorms bring heavy rains that cause flooding. Flooding happens when water flows onto land that is usually dry. Floods can uproot trees, destroy buildings, and carry away cars. Thunderstorms may cause flash floods. These are floods that happen suddenly. Flash floods most often occur in low areas or in spots where rain flows into narrow places. Flash floods are dangerous because they happen so quickly that people do not have time to get out of their way. About half of the people who die in flash floods are killed when the cars they are driving are swept downstream. Spinning winds. A tornado is a column of spinning wind. Most tornadoes form in large thunderstorms called supercells. Supercells have strong updrafts that cause vertical columns of spinning wind inside thunderclouds. Tornadoes form when these spinning winds drop from the clouds and touch the ground. One thunderstorm can cause many tornadoes. These can happen at the same time or on and off as a storm moves along. Tornadoes can be 1 mile, 2 kilometers wide, and spin at speeds of more than 300 miles per hour, 483 kilometers per hour. They can blow over buildings, rip trees from the ground, and kill people and animals. Learning about thunderstorms. Scientists use radar and satellites to track thunderstorms. The National Weather Service uses this information to send out warnings to the people in a storm's path. After a thunderstorm, scientists use the information gathered by radar and satellites to study how the storm grew and moved. Some people go right into storms to learn about them. They are called storm chasers. Storm chasers drive trucks carrying special tools to measure storm winds, temperatures, and moisture. Scientists use all of this information to build computer models of thunderstorms. These help them understand how the next storm might. Safety first. When the skies turn dark, go inside. Find a local weather report. If a thunderstorm is forming, stay inside until it passes. If you are caught outside during a storm, stay out of low, narrow areas that might flood. If there is thunder or lightning, get away from tall objects, water, and things made of metal. Crouch down into a tight ball. Being smart during a thunderstorm will keep you safe.
Caimans, gharials, alligators, and crocodiles by Bethany Baxter. Armored reptiles. Crocodilians are a group of reptiles that evolved more than 200 million years ago. They lived on Earth with the dinosaurs, yet they are still around today. Today, this group is made up of caimans, gharials, alligators, and crocodiles. Crocodilians are known for having hard, scaly skin. Their scales act like armor that helps keep them safe from animal predators and people. There are 23 species of crocodilians alive today. The smallest is the Cuvier's dwarf caiman. It grows to be only 5 feet, 1.5 meters long as an adult. The largest is the Indo-Pacific crocodile. Adult Indo-Pacific crocodiles can grow to be more than 23 feet, 7 meters long. Warm, wet habitats. Most crocodilians live in tropical habitats. These places are near Earth's equator, where it is warm or hot all year long. Different species of crocodilians live in parts of Africa, India, Southeast Asia, Australia, North America, Central America, and South America. Sometimes crocodilians are named after the place they live, as the American alligator and Chinese crocodile are. All crocodilians live in wet habitats, such as swamps, ponds, rivers, lakes, and marshes. They spend most of their time in the water. Crocodilians may live in salt water, fresh water, or brackish water, which is a mix of fresh water and salt water, hard scales, and bony plates. Caimans, gharials, alligators, and crocodiles have skin covered in hard scales and bony plates. Their scales and plates keep them safe from most people and other animals. They shed their scales one at a time, instead of molting their skin, as snakes do. The color of many crocodilians' skin lets them blend into their habitats. All crocodilians have the same general body shape. They have long snouts, with strong jaws and many teeth. They also have long bodies with 2 legs on each side. Their long, muscular tails help them swim quickly. However, there are many differences between species as well. Living alone. Crocodilians are mostly solitary animals. This means they live alone as adults instead of in groups. Crocodilians are territorial. They defend their territories or living spaces from others in the same habitat. Some crocodilians are more dominant than others. Dominant crocodilians get to pick the best territories for hunting and resting. Crocodilians communicate by making noises. They roar, hiss, and growl at each other. They also slap their heads and snap their jaws against the water to mark their territories. Sometimes crocodilians fight with each other over territories. They smack their heads together and bite at each other. Eggs and babies. Male and female crocodilians mate in the water. However, female crocodilians lay their eggs on land. First, a female digs a hole in the sand or mud to make a nest. Then she lays and covers up the nest with more sand or mud. Smaller crocodilians lay only about 10 eggs, while large species may lay up to 50 eggs. The female stays with the nest to protect the eggs from predators. When the eggs start to hatch, the babies cry out. The female hears the cries and digs them out of the nest. Then she carries the babies to the water one at a time. Meat eaters. Crocodilians are carnivores. This means they eat only meat. However, they are not picky eaters. They generally eat what they can find when they are hungry. Their diets include fish, snakes, turtles, frogs, and birds. Large crocodilians also hunt mammals. Crocodilians lie still in the water until an animal comes close. Then they attack it very quickly. Crocodilians use their strong jaws and sharp teeth for biting and holding their food. However, they do not chew their food. Instead, they swallow it whole. The acid in crocodilians' stomachs helps them digest their meals, including animal shells and bones. What eats crocodilians? Large adult crocodilians have no animal predators. They are too big for other animals to eat. However, even smaller adult crocodilians are not in danger from other animals. They are kept safe by their hard scales, strong jaws, and fast swimming. However, crocodilian eggs and young crocodilians are often eaten by other animals. For example, lizards and foxes steal eggs from caiman nests. Young caimans are much smaller than adults. They are hunted by large fish, snakes, birds, and other crocodilians. Young crocodilians try to blend in with their habitats to keep safe from predators. They also call out to their mothers to protect them from other animals. Humans and hunting. Alligators, caimans, and gharials can live for about 60 years in the wild. Crocodiles live even longer, for 75 years or more. However, many crocodilians do not live that long. They are caught and killed by humans instead. Crocodilians are hunted for their meat and skin in many parts of the world. Their skin is used for clothing, shoes, and bags. People also collect crocodilian eggs for food. The populations of many crocodilian species have become very small because of hunting. In some places, it is now against the law to hunt crocodilians. However, poachers continue to hunt them and sell their skins. The future for crocodilians. Many species of crocodilians are in danger of dying out because of hunting. However, crocodilians are also in danger because humans are destroying their habitats. People are cutting down tropical rainforests and wetlands to build more homes and farms. When this happens, many crocodilians have no place to live. Crocodilians have been on Earth for more than 200 million years. People must work together to keep crocodilians and their habitats safe. We want to make sure these amazing reptiles will be around for many more years to come.
20 Fun Facts About Spiders by Raz Q. Wonderful World of Spiders. You probably know something about spiders already. They're everywhere. City parks, country fields, and even your house. You know they have many legs and use webs to catch insects. You might even know that many spiders are venomous, though only a few could harm people. There are about 42,000 species of spiders, and they all differ in some way. The more you read about spiders, the more you'll realize what amazing creatures they are. they'll seem a little less scary and a whole lot cooler. Icky and awesome arachnids. Fact 1. Spiders aren't insects. Many people think spiders are insects, but spiders are arachnids. While insects usually have wings, arachnids don't. Their bodies are divided into 2 parts, while insects have 3. Arachnids have 8 legs, not 6. Arachnids also don't have feelers or antennae, as insects do. Spider senses. Fact 2. Some spiders have no eyes. Most spiders have 8 eyes arranged in pairs on their head, but some have 2, 4, or 6 eyes. Others have none. These spiders live in dark places such as caves. Eyes wouldn't help them find food there. Fact 3. A spider's sense of sight depends on how they catch their food. Hunting spiders, such as jumping spiders or wolf spiders, have excellent eyesight. They need it to spot prey. Web-building spiders often have poor eyesight. Luckily, they just need to feel prey moving in their webs to catch them. They may see changes in light, though. Fact 4. Spiders can smell with their legs. Spider legs aren't just for walking, they're for sensing. Each leg is covered with special hairs that can feel vibrations. Movements of prey cause vibrations on the ground and in a spider's web. Other leg hairs actually sense smells in the air. Bizarre bodies. Fact 5. Spiders have 2 more legs that aren't really legs. Pedipalps are attached to each side of a spider's mouth. They look like legs, but pedipalps have special hairs that sense smells too. Some spiders use them to hold prey. Parts of the pedipalps help some spiders crush food. Fact 6. Spiders don't breathe through their mouth. Some spiders have book lungs, which look somewhat like the pages of a book. As blood runs through the book lungs, it trades carbon dioxide for oxygen, just like we do when we breathe. Other spiders breathe through air tubes called tracheae. Fact 7. Small spiders have really, really big brains. Tiny web-spinning spiders have brains so big they spread into their legs. Scientists think a large brain helps a small spider spin its webs as well as large spiders do. The smaller the spider, the more space the brain takes up in the body. Fact 8. Some spiders can walk on water. Fishing spiders have long, thin legs and light bodies. So light, they can walk on water. When they need to hide from predators, they dive into water and stay there for over a half hour. Their book lungs get air from bubbles in the water. Fact 9. All spiders have fangs. Spiders grab prey with their chelicerae. Each of these jaws ends in a fang. In most spiders, venom travels through the fang. It either paralyzes prey or turns its insides to liquid. Then the spider can drink its meal through its straw-like mouth. Webs and silk. Fact 10. Spiders make more than one kind of silk. Most spiders have different silk glands for making different kinds of silk. For example, many female spiders make one kind of silk for weaving webs, another for wrapping eggs, and another for trapping prey. Fact 11. Not all spiders spin webs. While about half of all spider species spin webs to catch their meals, the rest are hunters. Jumping spiders wait until prey is just a few inches away and then jump on it. However, they can jump more than 40 times the length of their own body. Fact 12. Trapdoor spiders like to play hide and seek with their prey. Trapdoor spiders dig a den in the ground and line it with silk. They make a door out of dirt and silk. When they feel a vibration above, they quickly swing open the door and give their prey a deadly bite. Mom and Dad spiders. Fact 13. Male spiders really show off for their mate. When a male spider is ready to mate, he tries to interest a female. Hunting spiders dance by waving their legs or stomping on the ground. Jumping spiders show off colorful hairs. Web-building spiders pluck the female's web almost like they're saying, "Look at me." Fact 14. Some female spiders lay 2,000 eggs. Spider eggs look like a drop of water. While some mother spiders lay 100 or more eggs, others lay just one. They may put their eggs in one pouch or sack, while some make several. They attach sacks to plants or carry them around. Growing up spider. Fact 15. Many baby spiders are born travelers. Some young spiders stay near their mother. She helps them find food to eat. Others climb high, spin a long line of silk called a drag line, and let the wind carry them someplace else. This is called ballooning. Fact 16. Young spiders can regrow a lost leg. Young spiders shed their skin, or molt, as they get larger. They grow until they burst out of their old skin. This may happen up to 12 times before they're adults. If they lose a leg, they'll grow a new one when they molt. Smallest and biggest. Fact 17. The smallest spider could stand on a pinhead. Male spiders are usually smaller than the females of a species. Many people think the male part2 spider is the smallest spider in the world. The part2 measures just 3/200ths inch, or 0.38 millimeters. It can be found on the Southeast Asian island of Borneo. Fact 18. The Goliath bird-eater tarantula would fill up a dinner plate. The Goliath bird-eater tarantula may grow to be 1 foot, 30.5 centimeters across. It got its name because someone reported seeing one eat a bird. This tarantula's fangs can be 1 inch, 2.5 centimeters long. It lives in South American rainforests. Spider predators. Fact 19. Some spider predators just pretend to get caught in their webs. Spiders do have predators, including lizards, snakes, frogs, and fish. One clever enemy, the assassin bug, pretends to get caught in a spider's web. When the spider feels its vibration, it runs over to bite it. Instead, the assassin bug kills the spider. Fact 20. Spider wasps are the spider's worst enemies. Spider's nastiest enemy is the spider wasp. Spider wasps sting spiders, sometimes killing them and sometimes paralyzing them. Then they bring the spider to their young as a meal. Spider wasps will pick fights with much larger spiders. Creepy but helpful. Every species of spider is different, and only a very small number could actually hurt a person with their venom. In North America, this includes the black widow and the brown recluse. However, even these spiders would rather run away than bite. One spider eats about 2,000 insects a year. These are insects that could otherwise be running around your house. Even more helpful are spiders that kill grasshoppers and other pests that eat the crops we depend on for food. So maybe spiders aren't so bad after all.
How Dolphins and Other Animals Use Sonar by Therese Shea. Clever dolphins. People love dolphins so much that they go to aquariums and on special boat rides just to see them. Dolphins charm us by doing tricks and leaping over waves. These mammals are known for their friendliness toward people as well as their cleverness. Dolphins are also known for the noises they make. Scientists think dolphins make noises by moving air through body parts below their blowhole. They squawk, whistle, click, and squeak. However, this isn't just noise, it's how they talk. Dolphins make noises for other reasons too. They use sound waves to navigate, find food, and avoid predators. Echo what? Sonar is short for sound navigation and ranging. Sonar is the use of sounds to find underwater objects and locations. People use sonar machines. They send out sounds which travel as waves and bounce back once the waves hit something. This is called active sonar. Some kinds of sonar pick up sound waves coming from another source. This is called passive sonar. Scientists, the military, and fishermen all use sonar. A dolphin doesn't need a sonar machine. It's in its body. Not only can dolphins use sounds to locate something in deep, dark water, they can tell its size, shape, speed, and distance. An animal's use of sonar is often called echolocation. Underwater echoes. Dolphins are great at using echolocation. The dolphin makes a clicking noise. The sound goes out through the dolphin's forehead as a sound wave. This sound wave travels until it hits something. It then echoes back to the dolphin. The sound wave is detected by the bones in the dolphin's jaw and then its ears. The information sent through the echo goes to the dolphin's brain, which tells the dolphin about the object. By using echolocation, the dolphin can tell what an object is, how fast it's going, and in what direction. A dolphin's echolocation is so good that scientists study it to find out how to improve man-made sonar. Toothed whales. Dolphins aren't the only animals that use echolocation. They're not even the only animals in the ocean that do. It's thought that most toothed whales use echolocation. What are toothed whales? They include dolphins as well as porpoises, orcas, pilot whales, sperm whales, narwhals, and beluga whales. Not all toothed whales have the same echolocation abilities. For example, porpoises are prey for orcas. Porpoises' echolocation clicks may have become higher in frequency over many years until orcas couldn't hear them. However, an orca can still use its own echolocation to catch a porpoise snack. Bat biosonar. Animals that live out of the water use echolocation too. Much like dolphins and other toothed whales need echolocation in dark waters, most bats need echolocation because they're nocturnal. That means they're mostly active at night. They need to use echolocation to find food in the dark. Bats make noises much like we do. They move air past vocal cords. The sound either comes out through their mouth or nose, depending on the kind of bat. The noise is such a high pitch that people can't hear it. Still, the sound travels as waves, bounces off an object, and echoes back to the bat. Echo to ear. The echoing sound can tell a bat a lot about an object. Scientists think the folds in a bat's ears help it detect if the object is above or below. A small object reflects or sends back less of the sound wave. A big object reflects a bigger sound wave and makes a stronger echo. The pitch of the echo tells the bat what direction the object is moving. An object moving away sends back an echo with a lower pitch than the sound the bat made. An object moving toward the bat gives off an echo with a higher pitch. Oil birds and swiftlets. Some kinds of birds use echolocation too. The most famous are the South American oil birds or guacharos. This bird lives in caves, leaving only to find food at night. Since the oil bird lives most of its life in darkness or very low light, echolocation helps it find its way around. It uses biosonar to navigate inside its cave and to find fruit outside the cave. People can hear the echolocating sounds oil birds make, unlike the biosonar sounds of dolphins and bats. An oil bird can make nearly 250 clicking sounds per second. Shrew sounds. Scientists are still discovering animals that use echolocation. Shrews are one of these recent discoveries. These small mole-like mammals have tiny eyes and poor eyesight, but they have excellent senses of smell and hearing. Like many animals that use echolocation, shrews are mainly nocturnal. They make high-pitched sounds. Studies have shown that these sounds are used in echolocation to find out about surroundings and the best way to travel through them. Shrews may also use echolocation to find bugs and other small animals to eat. Shrews need to eat a lot to stay alive, so echolocation is very important for them. Disrupting the sound. Unfortunately, echolocation doesn't help animals see everything. For example, echolocation doesn't detect some fishing nets, so dolphins and other small-toothed whales can still be caught and killed. Also, boat motors and underwater drills make sounds that disrupt echolocation. While we're not sure if people's actions affect bat echolocation, we do know that wind turbines kill nearly 900,000 bats per year. Bats, oil birds, and shrews are also at risk when people take over their habitats. However, people can do things to help animals with biosonar. Turn the page to find out more.
20 fun facts about dragonflies. Maria Nelson. Life on the wing. With its 2 pairs of pretty wings, a dragonfly looks graceful as it flies around its pond or lake home. Did you know the dragonfly is also a swift and deadly predator? From its 6 legs to the many lenses of its eyes, some of the coolest dragonfly features help it catch prey. There are about 2,500 species or kinds of dragonflies. Whether you're in your backyard or on vacation in Africa or India, you might see these amazing insects. Let your colors show. Fact 1. Dragonflies can be as colorful as butterflies. From yellows and reds to browns and blues, dragonflies can show some wild colors. They might be shiny or even be spotted. While some species of dragonfly are more colorful than others, each dragonfly has its own special look. Fact 2. Dragonfly wings may look weak, but they're actually rather tough. Some of a dragonfly's coloring may come from its beautiful wings. Transparent as well as colorful, their wings are strong, even if they don't look it. Dragonflies commonly have a wingspan between about 0.8 inch, 2 centimeters, and almost 8 inches, 20 centimeters. Sun lovers. Fact 3. Dragonflies like it hot. Dragonflies are ectothermic, or cold-blooded. This means that how hot or cold a dragonfly is depends on its surroundings. You'll see the most dragonflies on warm, sunny days. That's what they like best. Fact 4. Dragonflies use the sun to get moving. Dragonfly wings work best when they're warm. In the morning, you might see a dragonfly perched on a leaf, soaking up some sun, or beating its wings very quickly to warm up. They like the sun so much, they might not even come out on cool or cloudy days. Superflyers. Fact 5. A dragonfly could keep up with a moving car on a city street. Dragonflies are fast. They can reach speeds of about 35 miles, 56 kilometers per hour. The southern giant darner dragonfly is known as the fastest flying insect. Dragonflies are such good flyers that scientists have built robots modeled to fly like them. Fact 6. A dragonfly uses its wings to fly around or stay put. Dragonflies have 2 sets of wings. They can move these together or separately. This movement allows dragonflies to fly up, down, or backward and make quick turns. They can also hover like a helicopter. Fact 7. Dragonflies can hide while flying. Dragonflies use agile flying to avoid predators. Some dragonflies can copy the tiny motions of a watchful predator so quickly and exactly that the predator can't even see them move. This hides them from animals looking for movement that could mean a snack. Fact 8. Dragonflies catch their prey while flying. In ponds without big fish, dragonflies may be the top predator. Dragonflies are carnivores, or meat eaters. However, the meat they eat isn't chicken or a hamburger. Dragonflies use their feet to catch mosquitoes, gnats, and even dragonflies smaller than themselves. Fact 9. The globe skimmer dragonfly travels 11,000 miles, 17,700 kilometers round trip. Many kinds of dragonflies migrate. These species are avoiding cold weather or flying to places that are good for mating. In 2010, a scientist studied the migration of the globe skimmer. These dragonflies fly from India across the Indian Ocean to East Africa. Life in the pond. Fact 10. Dragonflies start their life in fresh water. Dragonflies hatch from eggs laid in or near fresh water. After adult dragonflies mate, females lay hundreds of round eggs. Depending on the species, these eggs are about 0.02 to 0.04 inch, 0.5 to 1 across. Fact 11. Dragonfly nymphs use gills to move and breathe. Dragonfly larvae are called nymphs. These young dragonflies have 6 skinny legs, 2 big eyes, and a small body. Nymphs breathe in water using gills like a fish does. By pushing water out through these gills, nymphs can jet through the water. Fact 12. A dragonfly without wings is still a predator. Dragonflies may remain nymphs for several months or more than a year. Nymphs use pinching mouthparts to catch prey, such as other insects and even tiny fish. Nymphs eat lots of prey so they can grow and eventually get their wings. Lots of growing to do. Fact 13. Dragonfly nymphs may shed their skin up to 20 times. As nymphs grow, they molt or shed their skin. It's during its many molts that a dragonfly's wings first appear. When it's big enough, the nymph crawls out of the water and molts one last time. Fact 14. Predators love molting nymphs. A nymph becomes an adult dragonfly after its last molt. However, the dragonfly has to wait for its new exoskeleton to harden before it can fly. Predators eat many dragonflies during this time. Ducks, big fish, and frogs are some animals that enjoy a dragonfly meal. As an adult. Fact 15. Dragonflies can see almost all the way around their heads. Dragonflies have sharp eyesight to help them catch prey. Much of their head is taken up with 2 large eyes. Each eye is made up of almost 30,000 lenses. About 80% of a dragonfly's brain is used for sight. Fact 16. Male dragonflies need territory to win a mate. Female dragonflies want to mate with a male that has territory right on a pond or lake. This allows her many good places to lay eggs. Male dragonflies will fight off other males to guard this territory and their mate. Fact 17. Want to know if an area is healthy? Look for dragonflies. Different species of dragonflies like different bodies of water. However, dragonflies only live and mate near fresh water that's clean and in areas that don't have a lot of pollution. Pollution affects some species more than others, but seeing dragonflies is commonly a good sign. What's in a name? Fact 18. Dragonflies have lookalikes. Are you sure you're looking at a dragonfly and not a damselfly? Dragonflies are part of the scientific group Odonata. These insects have large eyes, 2 pairs of transparent wings, and a long, thin body. Damselflies are odonats too. Fact 19. The first insects linked to dragonflies lived on Earth before the dinosaurs. Scientists have found remains or fossils of a group of insects called Protodonata that are more than 325 million years old. These bugs looked a lot like modern dragonflies, but had a wingspan of up to 30 inches, 75 centimeters. Fact 20. Dragonflies have some colorful nicknames. They're sometimes called the devil's darning needle. An old story about dragonflies says that children who tell lies would have their lips sewn shut by the insect. This explains a few of the names dragonflies are known as, such as darner, which means one who mends with needle and thread, or devil's darning needle. Dragonflies around the world. From their beautiful colors to their amazing flying skills, dragonflies are cool bugs. Since they're found all over the world, except in Antarctica, people of many countries have stories and ideas about them. In Japan, dragonflies are more than just something pretty to look at in the garden. They're a sign of power and victory. The Chinese see dragonflies as good luck charms. Native American tribes link dragonflies with speed and happiness. Wherever they're found, dragonflies will brighten anyone's day. 20 fun facts about beetles. Ariel Cheeger. Beetle creature features. Beetles have 6 legs, 2 feelers, and an exoskeleton. These amazing creatures can be very beautiful, helpful, and even entertaining. They also show off many wonderful colors, crazy horns, and odd habits. Would you believe there are more beetle species, or kinds, than there are species of any other group in the animal kingdom? They make up about 40% of the entire insect population. Beetles are definitely one of the strongest and most successful groups of animals on the planet. They've outlived many other animal species, including dinosaurs. Where in the world? Fact 1. No matter where you go, it's hard to get away from beetles. Beetles can be found almost everywhere, except in places where it's very cold. They live in freshwater and saltwater and on land. Some beetles even survive in hot springs. Many beetles live under the bark of trees, both living and dead. Fact 2. Beetles have the largest number of species of any animal in the world. There are over 350,000 species of beetles, more than 1/4 of all animal species. Beetles vary greatly in size and shape. The rhinoceros beetle is the largest. It can grow to 7 inches, 18 centimeters long. The smallest beetles measure less than 0.04 inch, 1 millimeter long. Growing up fast. Fact 3. Some beetles live less than a month. Others live for many years. Some beetles live no more than 3 or 4 weeks. Others can live up to 12 years. Longhorned beetles eat the dry wood in which they live. Since wood isn't very nutritious, they spend most of their lives as larvae. Fact 4. Adult beetles don't live very long. Once a beetle completes the process of metamorphosis and becomes an adult, its life's journey is just about over. A beetle spends most of its life as a larva. Adult beetles rarely live more than 6 months. Beetle body armor. Fact 5. Beetles have their own suit of armor. A beetle's hard exoskeleton keeps it safe. It also has two sets of wings. The outer wings, called elytra, are hard. Elytra don't help the beetle fly. They help protect the beetle's body. They also protect the soft inner wings, which are used for flying. Fact 6. Beetles don't breathe through their mouth. They breathe through holes in their armor. Spiracles are openings along a beetle's body that allow the insect to breathe. Beetles take in air and make pumping movements to force the air throughout their body. The beetles use muscles to open and close spiracles so they don't lose too much water. Beetle talk. Fact 7. Beetles use smelly chemicals to find each other. Beetles can't see very well, so they depend on chemical scents to help find each other. Female beetles produce and release scent chemicals called pheromones. Male beetles locate females by following the trail of the scent. Fact 8. To talk to each other, beetles make sounds and vibrations with their body. Beetles make sounds by scraping their mouth parts together and rubbing their legs together. The process of rubbing body parts together to communicate is called stridulation. Beetles that live in a dead log create vibrations to communicate with beetles in other parts of the log. What's for dinner? Fact 9. Just about any creature can be a meal for beetles. Beetles are decomposers. That they break down and eat many things, including leaves, sticks, grass, dead animals, animal waste, and much more. Almost every product of the animal and plant kingdoms supplies some species of beetle with food. Beetle battles. Fact 10. Beetles fight each other for food, sometimes to the death. Some beetles, such as stag beetles and dung beetles, fight over food. Some even fight until one beetle kills the other. Ladybird beetles, or ladybugs, have been known to lie on their backs and play dead, just like they would if attacked by a predator. Fact 11. Beetles give off terrible odors when they're in trouble. When beetles are in danger, some stand on their head and release chemicals from a body part in their rear. The chemicals smell really bad and can turn other animals' skin brown. The horrible smell of the beetle's scent scares off predators. Fact 12. Some beetles can burn, sting, and bite their predators. Some beetles have a more painful defense. Bombardier beetles spray a burning, stinging fluid from their abdomens with surprisingly good aim. Ladybird beetles, blister beetles, and soldier beetles store defensive chemicals in their blood and release them through their leg joints when attacked. Ding dong! Fact 13. Dung beetles make good use of poop. The dung beetle uses other animals' dung, a fancy word for poop, to eat, lay their eggs in, or even live in. Some dung beetles roll the dung into a ball and move it away for later. Some bury it in underground tunnels. 14. Dung beetles help new trees grow. When animals eat fruit, the seeds sometimes come out in the animal's waste. Dung beetles move the waste elsewhere and bury it. This puts the seeds safely in the ground. Dung beetles help the environment by planting new trees. Beetles throughout the ages. Fact 15. Beetles have been around since the time of the dinosaurs. The earliest known beetles existed nearly 300 million years ago, along with the dinosaurs. Once plant life started to grow, beetles began to reproduce at an incredibly fast rate, surviving on the food that plants provided. Fact 16. Beetles have outlived many other animal species. Beetles have been around longer than many other kinds of animals. Their exoskeletons protect them from predators. Flying allows them to escape danger. They can dig holes and even swim, which allows them to survive changes in weather and climate. Bundles of beetles. Fact 17. Some people have worn beetles as jewelry. Beetle colors vary from dull brown to bright greens, blues, and purples. Some are even shiny. Fireflies are beetles that light up the night sky. In Europe and Asia, beetle wings have been used as ornaments for paintings and have even been worn as jewelry. Fact 18. People around the world eat different types of beetles. Did you know some people actually eat beetles? Beetles are high in fat and protein, which help people survive in places where there's not always enough food to eat. In some Asian countries, adult beetles and even larvae are considered delicious treats. Name that beetle. Many beetles have been named after objects, sounds, movements, places, and other animals. Rhinoceros beetles are named for their large horns. Christmas beetles were named in Australia for their glittery green color and because they suddenly first appeared around Christmas time. Helpful or harmful? Fact 19. Japanese beetles can ruin your garden. Many beetles feed on the roots, wood, leaves, flowers, and fruit of living plants. Japanese beetles are very pretty, but the adults love to eat green leaves. The larvae love to eat roots. They can be a gardener's worst enemy. Fact 20. Ladybird beetles can save your garden. Ladybird beetles, or ladybugs, are interesting to look at, but they're also very helpful. They eat other insects that are pests, such as aphids and mites. However, a few ladybird species are pests themselves because they eat crops. Beetle invasion. The Asian longhorned beetle is an invasive species. That means that it moves into a new area and hurts the local environment. The longhorned beetle eats and destroys many trees. It makes its nest inside piles of firewood. When the firewood is moved or disturbed, the beetles seek out and destroy new trees. To protect trees and let beetles live in peace, never move firewood from one forest to another. This will stop the beetles from seeking homes in new trees.
How Cats and Other Animals See at Night by Christine Honders. Night Sight. Have you ever wondered how cats can sneak around the house at night without knocking anything over? How can some animals live in the woods and always find their way in the dark? Some animals are awake all night long and sleep during the day. Animals need to adapt to changes in the world around them in order to stay alive. Some have adapted a strong sense of smell or hearing. This book will focus on animals that can see in the dark, including many different kinds of cats, from mountain lions to house cats, living in the dark. People sometimes get nervous in the dark because they can't see well and don't know what's around them. For some animals, night is their time to work and play. They are at their best in the dark because of their senses, including night vision. Animals that are most active at night are called nocturnal animals. Animals are nocturnal for many reasons. In very hot places, it's much cooler at night. Bats fly at night so they don't have to fight with birds to get food. It's also easier for animals to hide from predators at night. How big your eyes are! Cats, like many nocturnal animals, have big eyes. Their pupils open more widely than those of animals that don't see well at night. Pupils are the dark spots in the middle of the eye that let light in. Larger pupils allow more light into the eye, making it easier to see in the dark. When a cat's pupils are at their widest, they cover almost the entire front of its eyes. Cat's eyes let in so much light that they only need about 1/6 of the light humans need in order to see. Rods and cones. After light enters the pupil, it goes through the lens and onto the retina. The retina is the control center of the eye. It's connected to the brain. The retina has two kinds of light-sensing cells, called rods and cones. Cones work in bright light, and rods are what help the eye see in low light. Cats and other nocturnal animals have retinas with many rods and very few cones. Rods don't let eyes see colors, but cones do. Most nocturnal animals don't see color well, since they don't have many cones. Mirror, mirror in the eye. Cats also have a mirror-like layer behind the retina called the tapetum lucidum. The tapetum lucidum reflects light back through the retina a second time, so the rods have another chance to collect it. When you shine a light into a cat's eyes at night, they appear to glow. The glow is the light reflected by the tapetum lucidum. Not every nocturnal animal has the same color of glowing eyes. Cat's eyes shine green, while deer and raccoons' eyes are more yellow when they glow. Foxes' eyes usually shine white when they're caught in car headlights at night. Here comes the sun. Because cats' eyes are so good at catching light in the darkness, they're sensitive to bright light. That's one reason why nocturnal animals aren't very active during the day. However, some nocturnal animals, such as house cats, are awake during the day. How do they see without hurting their eyes? Humans have round pupils, which are great for daytime vision, but aren't very good at keeping light out. Cats and other nocturnal animals have slit pupils. Special muscles work like sliding doors to close the pupil quickly and keep the bright light out of a cat's eye, except for a tiny strip of light. Who else can see in the dark? Cats see better at night than most mammals, including humans. Owls have better night vision than most other birds. What other animals see well in the dark? The tarsier is a small mammal that lives in southeastern Asia. Tarsiers are nocturnal animals with huge eyes that take in as much light as possible at night. In fact, they have the largest eyes of any mammal in proportion to their size. Like owls, tarsiers' eyes can't move in their sockets, but their neck turns their head much farther than many other animals, underwater and in the air. Some animals live in ocean water so deep that sunlight can't reach them. One of these animals is the giant squid. It has eyes the size of dinner plates. These large eyes help it see its prey in dark ocean waters. The spookfish is a fish that lives deep in the ocean. Scientists once thought it had 4 eyes. Now they know spookfish have 2 eyes split into halves. One half looks up, and the other half looks down into the dark. It also has mirrors in its eyes instead of lenses to aim light onto the retina. Turn off the lights. Sometimes the things people build light up the darkness all night long, creating a problem called light pollution. This can be dangerous for nocturnal animals. They can't hide from predators. Their eyes are made for seeing in the dark and are sensitive to even tiny amounts of light, which can confuse them. They may stay away from areas where they've always lived in order to get away from the light. Even the smallest change in surroundings can affect animals. If they move to an unfamiliar place to get away from bright lights, they may not know where to get food, have their babies, or hide from predators. Superior sight. The changes that light pollution brings to an area are harmful to nocturnal animals. People can help by making sure their outside lights are off at night. Cats have some cool abilities. They're great hunters. They can balance themselves almost anywhere. And they have excellent senses of smell and hearing. However, their most superior sense is their sense of sight. The next time you see your cat's eyes shine in the darkness, remember, that's how it can see you.
Vampire Bats by Rachel Lynette. Thirsty for blood. Can you imagine living on blood? If you were a vampire bat, that is exactly what you would do. Vampire bats are the only mammals that must drink blood to live. There are more than 1,200 species of bats, but only 3 of them are vampire bats. The white-winged vampire bat and the hairy-legged vampire bat feed mostly on birds' blood. The common vampire bat is the most widespread species. Common vampire bats usually feast on larger mammals such as cows, pigs, and horses. Where do vampire bats live? If you want to see vampire bats in the wild, you will need to go to Mexico, Central America, or South America. Vampire bats prefer the warm, humid forests and grasslands found in these places. Vampire bats live together in groups called colonies. There are 20 to 100 vampire bats in most colonies, but some colonies have 1,000 bats or more. Most vampire bat colonies make their homes in caves. A colony may also settle in a large, hollow tree, a mine shaft, an old well, or an empty building. Flying and crawling. Most vampire bats are only about 3.5 inches, 9 centimeters long. With its wings spread out, a vampire bat is about 8 inches, 20 centimeters wide. Vampire bats have light, thin wings. Unlike most other kinds of bats, vampire bats can easily crawl, jump, and even run along the ground. Vampire bats crawl by using the strong forelimbs that are attached to their wings, rather than their weaker back legs. These forelimbs have special clawed thumbs that help them crawl and climb. Special senses. Like other bat species, vampire bats use echolocation to avoid flying into objects. The bats send out a high-pitched sound that echoes or bounces off objects in front of them. The echoes tell the bats how close they are to these objects. Vampire bats have a much stronger sense of smell than humans do. They can use their sense of smell to find prey. In a herd of animals, a vampire bat can use its sense of smell to find an animal it has preyed on before. A vampire bat often preys on the same animal again and again. A bloody diet. Vampire bats live on blood. They cannot eat solid food because they have very narrow throats and zigzagging stomachs. A vampire bat needs about 2 tablespoons of blood each night. A vampire bat feeds on just one animal each night. It uses its sharp incisor teeth to take a tiny bite. The bat drinks the animal's blood by using its tongue in the same way that a cat laps milk. Share and share alike. Vampire bats are nocturnal. This means they are active at night. During the day, vampire bats roost together, sleeping while hanging upside down. When they are not sleeping, they may spend time grooming each other's fur. A bat cannot go more than about 2 days without feeding. Young bats that are still learning to hunt sometimes fail to get food. When this happens, other bats will help them by regurgitating or vomiting blood into the hungry bat's mouth. Drinking regurgitated blood sounds gross, but it saves many young bats from starving to death. Baby bats. After mating, a mother bat gives birth to one baby about 7 months later. For the first 2 months, the baby drinks only its mother's milk. Then the mother starts to feed the baby regurgitated blood. At 4 months, the young bat starts to hunt with its mother. Mother vampire bats often help one another by feeding one another's babies. If a baby is orphaned, another mother may adopt it. Vampire bat predators. A vampire bat risks its life every night when it goes out to hunt. Vampire bats have several predators, including eagles, hawks, owls, and snakes. Hawks have been seen waiting near the mouths of caves, ready to feast on returning vampire bats. Snakes may attack them from trees. Vampire bats also risk being squished to death by their sleeping prey. If the animal a vampire bat is preying on wakes up, it may roll over or step on the tiny bat. A vampire bat is so small that even the swat of a cow's tail could end its life. Friend or foe. Even though vampire bats do not take enough blood to kill an animal, they can still cause a lot of damage. The wounds they create while feeding can get infected. Vampire bats can also carry rabies. Rabies is a sickness that kills animals. Many people are afraid of vampire bats. They may think of vampire bats as giant, blood-sucking monsters. There is little reason to worry about them, though, because vampire bats rarely bite humans. Scary facts. 1. The saliva of a vampire bat contains a substance that stops an animal's blood from clotting. The blood then keeps flowing so that the bat can drink it. 2. Vampire bat roosts are messy and smelly. The walls and floors are covered in slimy, digested blood droppings. 3. Vampire bats often go to the bathroom while feeding. This makes it possible for them to drink more blood. 4. Vampire bats also go to the bathroom when they finish feeding in order to lighten their blood-heavy bodies for flying. 5. Scientists are worried that as vampire bat populations grow, the bats may attack people more often. Attacks are on the rise in Peru. 6. A vampire bat must drink half its weight in blood every night. 7. Often, several vampire bats feast on the same animal at once. 8. In the 2005 movie Vampire Bats, mutant vampire bats attack the people of a small town. 9. A colony of 100 bats can drink the blood of 25 cows in a year. Tell me the difference between a bee and a wasp, by Lee Rockwood. Let's look at bees and wasps. Bees and wasps are both insects known for their stings. It can be hard to tell them apart without looking closely. Scientists group these animals into a suborder called Apocrita. A suborder is a group within an order that has a lot in common. Believe it or not, ants are among the thousands of species that belong to this suborder too. Bees and wasps share many physical characteristics and some behaviors, but each type of animal has qualities that set it apart. This book will show you how to tell the difference between the two insects. When a family is a superfamily. Bees and wasps belong to an order with many different species. For this reason, scientists further break down the Apocrita suborder into several superfamilies. A superfamily is a group of scientific families with an order or suborder that has a lot in common. Apoidea contains all of the more than 16,000 bee species and many kinds of wasps. Another superfamily, called Vespoidea, contains another group of roughly 5,000 wasp species. Among the species in this group are wasps commonly known as paper wasps, hornets, and yellow jackets. With so many members, it is no wonder that it is hard to tell bees and wasps apart. How are bees and wasps alike? Bees and wasps share a similar body plan. As do other insects, they have bodies that are divided into 3 parts. First, there is the head, which has 2 antennae and compound eyes. Behind the head is the thorax, where 2 sets of wings and 6 legs are attached. In both animals, the thorax narrows into a waist, where it meets the abdomen. The abdomen is where the dreaded stinger is found on both bees and wasps. That stings! Both bees and wasps are known for their stings, which deliver a dose of venom. Only females have stingers, though. Bees use their stingers only for defense. Wasps are more aggressive stingers. They will more readily sting for defense, and some species also sting prey. You may have heard that bees can sting only once. This is true only of honeybees. These bees have stingers with more barbs than other wasps and bees have. This means that when a honeybee stings, the barbed stinger gets stuck in the skin. As the honeybee tries to pull the stinger out, part of its body rips off, killing it. Other bees and wasps' smooth stingers can sting more than once. Buzzing bodies. Although bees and wasps share a body plan, there are differences in the way their bodies are shaped. Wasps' abdomens have a more pointed shape, while a bee's is more rounded. Additionally, the point at which a wasp's thorax and abdomen meet is much thinner, giving it the look of a more slender waist between the 2 body sections. You are likely most familiar with the yellow and black stripes that bumblebees, honeybees, and many wasps have. Bees and wasps come in lots of other colors, though. For example, orchid bees, which live in tropical South America, can be iridescent shades of blue or green. Bee and wasp diets. Another way that bees and wasps differ is in their diets. Bees are herbivores. They eat only pollen and nectar from plants. They have long, tube-like mouth parts called proboscises that they use to drink nectar. Bees usually have hairy bodies or hairy legs, which they use for collecting pollen. Wasps often prey on other insects or spiders, which they kill using their stingers. They have mandibles or jaws instead of proboscises for eating their prey. Some wasps eat too, but all wasps have smooth bodies and do not collect pollen. Home sweet home. You cannot escape bees and wasps unless you move to Antarctica. Both insects are found throughout the world in nearly every habitat. Some bee and wasp species are solitary or live alone. Solitary wasps may build small nests or live in holes in walls. Solitary bees most often make homes in small holes in the ground. Some bee and wasp species are social or live in groups. Many social wasps build nests using mud or by chewing up wood and plant parts to make a paper-like material. Social bees build hives in places like hollow tree trunks. They then start making combs out of beeswax, which is made in their own bodies. Bee and wasp life cycles. Bees and wasps go through similar life cycles. The queen is the female that mates with male drones and lays eggs. Fertilized eggs will hatch as females, and eggs that are not fertilized will hatch as males. Worker bees and wasps you see outside of the nest or hive. They build the nest, gather food, and feed the young. The young, or larvae, undergo changes before becoming adults. As the larva grows, worker bees feed it. Then the workers seal the larva into its cell with beeswax. Inside the cell, the larva forms a cocoon and transforms into a pupa. The pupa eventually changes into an adult bee and leaves the cell. Now you know. Although bees and wasps can cause painful stings, you can appreciate the ways they benefit people. They pollinate plants, which brings the flowers we enjoy, and the fruits and vegetables we eat. Honeybees make the honey we eat and the beeswax we use to make candles. Many wasps prey on other insects we consider pests. Bees and wasps are all around you, and now you know ways that you can tell them apart.
Arabian Horses by Lorijo Metz. Arabians. The Arabian horse is one of the oldest known breeds or types of horses. The Bedouins first raised these graceful horses. The Bedouins are a people who live in the deserts of the Middle East. Scientists think that the Bedouins may have started raising Arabian horses almost 5,000 years ago. Arabian horses now live in many parts of the world. Known for their beauty and speed, Arabians are one of the 10 most popular breeds of horses. They are also famous for winning long-distance races, like the Pan American Endurance Championships. Most important, they are good with people. Gentle, hot-blooded horses. Life in the desert where Arabians began was hard. Days were hot and nights were cold. Food and water was hard to find. Arabians and humans learned to depend on each other. While Arabians helped people cross the hot desert sands, people made sure their horses had plenty of food and water. This special bond between Arabian horses and people continues today. While Arabians are gentle and loving, you may often hear them called hot-blooded. This is because Arabians are lively and fast. However, they are also smart and easy to train. When trained right, Arabian horses are easy to work with. Proud Arabian beauties. Most Arabians are solid colors, such as gray, brown, and chestnut. Chestnut horses have reddish-brown coats, manes, and tails. Some Arabians are bay, or reddish-brown with a black mane, tail, and legs. Arabians have small pointed ears and large dark eyes. Like upside-down triangles, their heads narrow to small noses and mouths or muzzles. Arabians have dished faces, which means they curve in just below the eyes. Their necks are thin and graceful. Their manes and tails are silky and long. People say that Arabians must know they are beautiful, since their tails are always held high. Caring for Arabians. Arabian horses need plenty of open land for exercise. They also need housing, such as a barn or stable with their own stalls filled with clean straw to sleep in. Daily brushing is important to keep their coats and skin clean. A visit once a year from a veterinarian or animal doctor is also very important. Though years of desert living made Arabian horses able to survive on less, they still need plenty of fresh food and water. Arabians eat hay and alfalfa. When working hard, they also eat oats, barley, and other grains. To replace salt lost from sweating, they need blocks of salt to lick. Foals. Female horses are mares. Mares carry their babies, called foals, for 11 months. Minutes after birth, foals take their first shaky steps. Soon after, they are drinking their mother's milk. Within a day, they are up and running. Foals remain with their mothers for between 4 and 5 months. After that, they spend most of their time with other young horses. Horses are measured in hands. 1 hand equals 4 inches, 10 centimeters. Arabian horses grow to be from 14 to 15 hands high. They are measured from the ground to the tops of their withers, or shoulders. Arabians in the desert. Arabian horses come from a part of the Middle East known as the Arabian Peninsula. The Bedouins who raised them lived in tribes. They also raised animals such as goats and sheep. Bedouins moved around the desert so that their animals could find plants to eat. They lived in tents. The Bedouins were often at war. They needed horses that were fast and strong. Arabian horses could cover long distances with little water. Bedouins prized their horses, even sharing their tents with them. This was good for the horses and good for the Bedouins. If a stranger approached, stamp their hooves in warning. Arabians around the world. In the past, people used horses in wars. Most war horses were strong, but Arabian horses were both strong and fast. Once people from Europe, Asia, and America saw these horses, they wanted them. Arabian horses were often bred with other types of horses. Many breeds of horses have some Arabian blood. People other than Bedouins began raising Arabian horses too. In 1881, Wilfred Scawen Blunt and Anne Blunt brought Arabians to their home in Crabbett Park, England. They feared purebred Arabian horses, or Arabian horses that were not mixed with other breeds, might die out. Crabbett Arabians are still prized by people all over the world. Arabian horses today. Arabian horses now live in many parts of the world, from Australia and Spain to North America and South America. Today these horses are no longer used for war. Many people own and ride Arabians simply because they are beautiful. Years of living in deserts have made Arabians perfect for long-distance rides. People ride Arabian horses when hunting or trail riding. With their long, silky manes and tails held high, you also often see these horses in parades. Finally, their gentle way with people has made them popular in programs for people with disabilities, endurance racing, and horse shows. Arabians are the stars of long-distance horse racing, known as endurance racing. One of the oldest endurance races is the Tevis Cup, covering 100 miles, 161 kilometers through the Sierra Nevada in California. It is one of the hardest endurance races. Since this race began, all but 2 of the winners have been part or purebred Arabians. Arabians are also popular show horses. In horse shows, Arabians compete or go up against other horses in classes. The halter class is like a beauty contest. Horses are judged by how they look. In the dressage class, horses must accomplish special riding moves. Beyond horse racing. Today, Arabian horses and people work together in many ways. In equine therapy, therapists use horses such as Arabians to help people overcome problems. Arabian horses even act in movies. In 1979, an Arabian named Cassoulet starred in the movie The Black Stallion. Many people wanted to own Arabians after seeing him. Whether racing across deserts or starring in movies, Arabian horses and people will always have a special bond. Camels by Willow Clark. Hello, camel. Camels are large mammals that are native to the deserts of North Africa, the Middle East, and Asia. There are 2 species or types of camels. The dromedary camel lives in North Africa and the Middle East. The Bactrian camel lives in Central Asia. Most of the camels living today are domesticated. That means that they have been raised to live among people and to do work for them. Camels have been so important to desert transportation that they are sometimes called the ships of the desert. This book will introduce you to these important Asian animals. Where in the world? Dromedary camels live in the deserts of North Africa, parts of India, and the western part of Asia called the Middle East. The climate throughout their range is hot year-round and very dry outside of a short rainy season. There are also feral dromedaries that live in Australia's desert. Feral animals are domesticated animals that have returned to the wild. These feral dromedaries came from the camels that were brought to Australia to work in the 19th century. Bactrian camels have a much smaller range than dromedary camels. They live in the deserts in northwestern China and southern Mongolia. The climate there is also dry. The temperature can be very cold or very hot, depending on the time of year. At home in the desert, camels have been domesticated for over 3,000 years. There are people living in desert habitats who use camels to do jobs similar to those that horses do. Camels' bodies can deal with harsher climates than horses, though. The deserts where camels live can be more than 120 degrees Fahrenheit, 49 degrees Celsius in the summer. Both dromedary and Bactrian camels have been domesticated. About 90% of domestic camels are dromedaries, though. The only truly wild camels left in the world are wild Bactrian camels. Wild Bactrian camels are very rare. It is thought that there are fewer than 1,000 left, which makes them a critically endangered species. This means that they could soon die out completely. One hump or two? The easiest way to tell the two camel species apart is to look at their humps. Dromedary camels have one hump, while Bactrian camels have two. You might think that camels' humps store water. This is not true, though. Camels' humps are fat stores. A hump can store up to 80 pounds, 36 kilograms of fat, which the animal can break down and use for energy when food is scarce. This means camels do not have to eat or drink every day. Amazing adaptations. Camels have many other adaptations to desert life besides their humps. Their nostrils trap most of the water in their breath as they breathe out. This water is put back into their bodies, so very little water is lost to the air when they breathe. Bactrian camels have adaptations to their fur to protect them from the cold winters in Central Asia's deserts. Temperatures there can drop to minus 20 degrees Fahrenheit, minus 29 degrees Celsius. They grow shaggier coats for the winter. They shed these coats as the temperature starts to rise. Even camels in hot deserts are helped by their fur. This fur helps keep the sun's heat away from their bodies. Time to eat. Camels are herbivores. This means that they are plant eaters. Their large, tough lips are split in the middle. This makes it easier for them to eat dry, tough, bitter, or thorny desert plants. Domestic camels eat foods like grasses, grains, and dates. Camels digest or break down food similarly to the way that cows do. First, they partly chew and swallow their food. This food later comes back up from the stomach. The camel then chews and swallows it one last time. This is called chewing the cud. This kind of digestion helps camels get the most nutrients possible out of their food. Defenses and communication. Did you know that camels sometimes spit? When a camel feels threatened, it will spit a mixture of stomach contents and saliva. This defense is meant to surprise the threatening animal and make it go away. Camels may also spit if they get very excited. They are generally not aggressive. The closest they get to fighting is pushing or nipping at each other. Both domestic and wild camels travel together in groups called caravans. A caravan is made up of a male leader, a few females, and their young. Baby camels. The camel's mating season happens in the fall and winter. During mating season, male camels may fight with each other over females. Males may spit at, bite, or even try to sit on their rivals. Baby camels or calves are usually born in the spring, about 12 to 14 months after mating. The calf can stand and walk a few hours after birth. The mother nurses her calf for about 18 months. The calf reaches adulthood at between 3 and 5 years of age. The camel's lifespan ranges from about 35 to 50 years. Camels and people. Domesticated camels have long been valued as pack animals. They carry people and loads over long distances in harsh conditions. They can carry a 200-pound, 90-kilogram pack for up to 25 miles, 40 kilometers each day. People also value camels for their milk, wool, leather, and meat. Their dung is even used for fuel. Although their camels are domesticated, most camel herders allow their animals freedom to roam. This allows the camels to spread out and graze on a wider area of the desert's plant life. Domestic camels depend on herders for their water, so this need draws them back home. Bactrian camels in danger. Wild Bactrian camels are critically endangered. This means that their numbers have dropped quickly and are expected to drop by 80% within the next few generations. Because there are fewer than 1,000 wild Bactrian camels left, they could even become extinct or die out. Wild Bactrian camels face several threats. They have lost part of their habitat to mining. They also are hunted, both for sport and because in some places they compete with domestic camels for food and water. There are groups working to protect the wild Bactrian camel so that it can continue to exist.
Bengal Tigers by Willow Clark. Hello, tiger. Tigers are the largest of the big cats. They are fearsome hunters that are known for their boldly striped coats and roars that can be heard as far as 2 miles, 3 kilometers away. There are 8 subspecies, or kinds of tigers, 5 of which are living today. The subspecies are Siberian, Indo-Chinese, South China, Sumatran, and Bengal tigers. Bengal tigers are the most plentiful tiger on Earth. Even so, they are an endangered species. This book will tell you more about these Asian animals, their habitat, and the reasons their numbers are falling. Where in the world? The Bengal tiger is found mostly in India. There are smaller populations living in the countries of Bangladesh, Bhutan, China, Myanmar, and Nepal. Bengal tigers like to live in places where there is water for them to drink and plenty of animals for them to hunt. They also like places with trees or tall grasses in which they can hide from prey. Adult tigers are mostly solitary animals. That means they live alone unless they are looking for a mate or are raising cubs. Bengal tigers need a lot of space, and as people have spread into once wild areas, the animal's natural habitat has shrunk. This is one reason Bengal tigers have become endangered. At home in the forest. Bengal tigers live in a wide range of habitats. They may live anywhere from grasslands to the foothills of the Himalayas. They also live in different kinds of forests, such as tropical forests, temperate forests, and mangrove forests. A mangrove forest is a swampy saltwater forest found in warm coastal areas. Unlike some members of the cat family, tigers are good swimmers. In fact, they are sometimes seen swimming across rivers or between small islands in mangrove forests. Sometimes they swim just to cool off. Territorial tigers. Unlike lions, tigers do not live in groups. Each adult has a home range, which it will defend from other tigers of the same gender. Bengal tigers that live where there is lots of prey generally have smaller ranges than tigers that live where there is less prey. Tigers communicate with each other by making noises such as roars, grunts, mews, and hisses. Each sound a tiger makes tells other tigers about its mood and where it is. Tigers also communicate with each other by leaving scent markings on their territories. Scent markings act like fences to tell other tigers to keep out. Why stripes? The tiger's striped fur certainly makes it memorable, but did you know that it works to camouflage the animal? Its coloring of brownish-orange fur with black stripes helps it blend in among tall grasses or in forests. The stripes break up the animal's outline, which helps it further disappear into its surroundings. That means that unsuspecting prey will not see the tiger until it is too late. Each tiger has its very own stripe pattern. Although most tigers are brownish-orange with black stripes, there are some Bengal tigers that are white with dark stripes. Claws and jaws. The Bengal tiger's claws and jaws are 2 great weapons that help it hunt. Like house cats, tigers have retractable claws. That means that their claws can go back into their paws when they are not needed to grab onto prey. This helps keep the tiger's claws sharp. Tigers can also sharpen their claws by scratching trees. This is another way for a tiger to mark its territory. The tiger's strong jaws have big, sharp canines. When hunting smaller prey, Bengal tigers will use their jaws to bite through the animal's neck bones. When hunting larger prey, Tigers use their jaws to attack the animals' throats. On the hunt. Bengal tigers are carnivores or meat eaters that hunt alone. Between dusk and dawn, they silently stalk prey through their territories. When they get within about 30 feet, 9 meters of their prey, they pounce. They grab the animals with their claws, pull them to the ground, and kill them with bites to the neck or the throat. After a tiger kills its prey, it drags it to a safe spot and eats. The hunt is not always successful. Tigers generally make a kill once every 10 to 20 hunts, or about once a week. On the menu. The tiger is at the top of its food chain. It is not on other animals' menus, although lots of animals are on its menu. The Bengal tiger's favorite prey includes wild boar, deer-like animals such as sambar and chital, and cow-like animals such as water buffalo and gar. Because hunting is hard work, tigers save the leftovers from their bigger kills. They bury this food in dirt and return to snack on it until it is gone. Tigers are not wasteful. They use their rough, sandpapery tongues to lick every last bit of meat from the animal's bones. Baby tigers. Male and female tigers meet up to mate and then return to their own ranges. 2 or 3 cubs are born 3.5 months later. Tigers can mate at any time of year, but it mostly happens between November and April. When they are born, Bengal tiger cubs are helpless. The mother must leave them alone in a safe place while she hunts, though. The cubs nurse until they are about 6 months old. Then the mother starts to teach her cubs how to hunt and kill prey. When they are about 2 years old, the cubs are ready to go off and find their own territories. Female cubs may choose a territory near their mother's territory. Tigers in trouble. There are only about 1,850 Bengal tigers left in the wild. These animals are in trouble due to habitat loss as well as poaching. Growing human populations are pushing tigers out of their natural habitat. People may also illegally kill tigers for their skin or to protect their livestock. Groups like the World Wildlife Fund are working to raise awareness about endangered animals like Bengal tigers. They also encourage countries to make and enforce laws that protect animals and their habitats. Their goal is to make sure that Bengal tigers' numbers grow so that they do not become extinct. Endangered Animals of Australia by Marie Allgore. Welcome to Australia. Australia is one of Earth's 7 continents. Australia is both a country and a continent. Australia is also an island. Many of Australia's animals are marsupials, such as the kangaroo. Indigenous Australians have lived on the continent for thousands of years. When Europeans began to settle in Australia in the 1700s, they brought their farm animals and pets. These Europeans cleared land for homes, roads, and farms. Some of Australia's native animals adapted to these changes. Other species have become endangered. Let's learn more about Australia's endangered animals and how people can help them. Australia's climate. Australia has different weather in different places. The kind of weather a place generally has over a long time is called its climate. Australia has a mix of tropical climates and temperate ones. The center of Australia is very hot and dry. Most of this part of the continent gets less than 10 inches, 25 centimeters of rain each year. The northern and northeastern parts of Australia get about 4 times as much rain as the central part. That means those places get 40 inches, 100 centimeters of rain each year. Southern Australia has hot summers and cool winters. Habitats in Australia. Australia has many different habitats. There are deserts, such as the Great Sandy and Tanami deserts. The bilby, the thorny devil, and the endangered rufous hair wallaby live in this hot, dry habitat. Australia also has temperate forests and grassy plains. Kangaroos and wombats live in these kinds of habitats. Australia also has rainforest habitats too. Birds, bugs, spiders, and many other animals make their homes there. Since the 1700s, more than 3/4 of Australia's rainforests have been destroyed. People are working to protect the remaining rainforests. This will help save the animals that live in this habitat. Numbat. Numbats are also known as banded anteaters. These small marsupials use their long noses to find termites. They then dig in the soil with their front claws and stick out their long, sticky tongues to eat their food. Numbats live in open woodlands and make their homes in fallen logs. These logs also give them a place to hide from dogs, cats, hawks, eagles, and snakes. Scientists guess that there are only 2,000 numbats left there. The biggest dangers to numbats are habitat loss and attacks from red foxes, dogs, and cats. Short-necked turtle. The short-necked turtle is Australia's most critically endangered reptile. It was put on the endangered species list in 1970 because there were only 250 turtles. Today, there are thought to be fewer than 25. This freshwater turtle has a square shell. It can be from yellowish brown to black. The turtles are endangered mostly due to habitat loss. Much of the swampland where this turtle once lived has been filled in for people's use. The swamps that are left are protected by the government now. Scientists have also started captive breeding programs for these turtles. Northern hairy-nosed wombat. Wombats live in burrows under Australia's dry grassland and woodland habitats. There are 3 kinds of wombats. These are the common wombat, the southern hairy-nosed wombat, and the northern hairy-nosed wombat. Both of the hairy-nosed wombat species are endangered, but the northern wombats are in the most trouble. In 1981, there were fewer than 20 northern hairy-nosed wombats left in Australia. Because of work to protect these animals and their habitat, there are about 113 today. These marsupials are still critically endangered. Gouldian finch. Gouldian finches are sometimes called rainbow finches because of their bright coloring. They can have black, green, yellow, and red markings and a purple chest. These finches can have red, black, or yellow heads. Gouldian finches live in tropical grassy woodlands. They eat mostly grass seeds and they nest in holes in trees. Farm animals, such as cows and sheep, eat grass before it has a chance to make seeds. This leaves the Gouldian finch without a food supply. People also burn the woodlands to make way for farms, which destroys the finch's habitat. Giant clam. Giant clams live in coral reefs in the Philippines, Micronesia, and Australia. These huge clams can live for 100 years in the wild. They have long been an important food supply for people in these places. People have also been trying to raise giant clams on farms and then let them go in their natural homes. Today, commercial fishermen gather those clams too. Giant clams are easy to collect and are now extinct in some places. The number of giant clams has dropped so low in Australia that it is now unlawful to collect them for food there. Save Australia's endangered animals. There are many reasons animals in Australia have become endangered or extinct. Some have not adapted to the non-native animals that have been brought to the continent. Others have lost their habitats to farms, businesses, mining, logging, roads, and homes. Australia's government is working to protect its animals. It has set aside conservation land. The government has captive breeding programs too. It is also working to teach the people of Australia ways to save native plants and animals. Australia's endangered animals. Australia has many incredible animals. The animals are endangered and could one day become extinct. 1. Corroboree frog. The tiny corroboree frog lives in forests and bogs high up in Australia's mountains. It is Australia's most endangered frog. 2. Gouldian finch. The colorful Gouldian finch lives in the woodlands and grasslands of Australia. Today there are only 2,500 left in the wild. 3. Greater bilby. The greater bilby is close to extinction because of fires in its desert habitat and because of habitat loss. 4. Leadbeater's possum. The leadbeater's possum lives in the trees in southeastern Australia and Victoria's Central Highlands. Today there are about 5,000 of these possums left. 5. Numbat. Numbats were once plentiful in the southern part of Australia. Now there are only 2,000 left in the wild. 6. Short-necked turtle. Short-necked turtles, also called swamp turtles, live in the swamps of Australia's Swan coastal plain. There are thought to be only 15 to 25 of these reptiles still living in the wild. Geese. Geese, Ganders, and Goslings by Loriho Metz. Waterfowl. Geese are part of the waterfowl family. Waterfowl are birds that swim and live near water. While the goose that laid the golden egg is only a fairy tale, real geese supply people with many useful things. For about 3,000 years, people have raised geese for meat, eggs, and feathers. Long ago, people used pens called quills, made from goose feathers. Today, many people in the United States, including members of 4-H clubs, raise geese to show at county and state fairs. Economically, however, goose farming remains most important in Asia and Central Europe. What do geese look like? Geese have long necks and fat bodies covered with feathers. They have flat beaks called bills. A goose's knees are hidden beneath its stomach feathers. The part of a goose that looks like a backward knee is really part of the goose's foot. As other birds do, geese walk on their toes. The rest of their foot never touches the ground. In most species of birds, males are more colorful than females. However, in almost every breed of geese, the males and females look the same. Pilgrim geese are the only exception. Male pilgrim geese are creamy white, while the females are olive gray. Swimming and flying. Geese have 4 toes. They have 1 short toe in back and 3 long toes in front. Their front toes are webbed. Their webbing makes goose feet look like paddles. It also makes them good for swimming. Geese swim by pushing their webbed feet backward and downward through the water. Wild geese are known for the V shape that a group of them makes when flying. Domesticated geese, on the other hand, do not spend much time in the air. Many of them do not fly well. Some are too heavy to fly at all. Others have had their wings trimmed so that they will not fly away. Wild geese and domesticated geese. Domesticated geese look much like wild geese. However, they tend to be larger. Many domesticated geese are raised for meat. They were bred to be big, to have more meat. There are 2 main groups of domesticated geese. Geese from Europe are descended from the wild greylag geese. Greylag geese are one of the largest kinds of wild geese in Europe. Geese from Asia descend from the wild swan geese. These breeds have longer swan-like necks. They also have lumps where their beaks meet their heads. They are often smaller than European geese. While wild greylag geese and swan geese are generally gray, some domesticated geese are almost all white. Breeds of domesticated geese. In the United States, Toulouse geese are one of the breeds most often raised for meat. People also raise these geese for exhibition. Toulouse geese raised for exhibition can weigh up to 25 pounds, 11 kilograms. Their bodies can be so large that they seem to drag on the ground. While most geese are raised for meat, you might be surprised to learn that people also use geese as guard animals. Geese will honk loudly at strangers. They have good eyesight, so they can see predators from far away. Though they are the smallest domesticated breed, Chinese geese make excellent guard geese. They are also the best egg layers. Fuzzy goslings. Mother geese lay eggs. After about 30 days, the eggs begin to hatch. The goslings inside tap on the eggshells with their beaks until the eggs break open. On some farms, goslings spend their days following their mothers around. On other farms, goslings are not raised with their mothers. Instead, they live with other goslings. Farmers use heat lamps to keep these goslings warm. They also supply the goslings with a dry place to stay when it rains. All goslings are born with down. These fuzzy feathers are different from the feathers adult geese have. Down does not keep goslings dry. What do geese eat? Geese eat mostly plants. Farmers feed geese grains such as corn. When they are outside, geese find their own food. They eat several kinds of grasses, but can be picky eaters. Farmers sometimes use geese to control weeds in crops, such as cotton and strawberries. The geese eat the weeds, but leave the crops alone. These geese are called weeder geese. They do not cost much to raise because they work for food. Like other birds, geese do not have teeth. They must swallow their food whole. After food passes through a goose's stomach, it goes to the gizzard. There, the food is broken down fully. Goose flocks. Geese live in groups called flocks. They are smart birds and remember things well. They form close bonds with other geese. Wild geese stay with the same partner or mate for life. On farms, geese do not mate for life. However, they are close to the other members of their flocks. Geese make loud noises called honks. No one knows exactly why geese honk, though. Some people believe they honk to say hello. Geese may also honk to warn of danger and to give encouragement to other geese. Eating geese. Goose meat is darker than chicken meat. It has a richer taste, too. In the United States, goose meat is most often eaten on holidays. In Northern Europe, people eat goose meat all year round. Goose eggs are common in dishes from China and other parts of Asia. Predators such as owls, foxes, and raccoons also like to eat geese and goose eggs. Farmers use fences to keep predators away from geese. They use dogs to guard geese too. Geese also fight back when they are in danger. They stick out their necks, hiss, and charge at their enemies. Goose down and more. Most geese that are raised for meat and eggs can also supply down and feathers. On an adult goose, down is a soft, fluffy layer of feathers found under a goose's longer outer feathers. It is used to stuff blankets, pillows, and winter coats. Goose down is soft and light. It is also very good at keeping in heat. People have been raising geese for thousands of years. In that time, we have found so many uses for these birds. Geese are here to stay. Migrating with the Caribou by Thessaly Cat. The Caribou's Journey. Many animals stay close to the places they were born for their whole lives. Other animals, such as caribou, go on a long journey every year. This journey is called migration. Caribou live in Alaska, northern Canada, Scandinavia, and Russia. The caribou that live in Scandinavia and Russia are most often known as reindeer. Every spring, caribou migrate toward the places where they were born. They travel in big groups, called herds. The herds return to their winter homes in the fall. Many herds travel hundreds of miles, kilometers, in each direction. Caribou have been making this journey for thousands of years. Antlers and hooves. Caribou are part of the deer family. They stand between 3 and 5 feet, 1 to 1.5 meters tall. Both male and female caribou have bony antlers on their heads. The caribou lives farther north than any other member of the deer family. It gets very cold in the places where caribou live. Caribou have shorter legs than other members of the deer family. Their short legs help them stay warm. Caribou have concave hooves on their feet. They use their hooves to dig up snow when they are looking for food. They also have a good sense of smell that helps them find food under the snow. Caribou in North America. In North America, there are 3 types of caribou. Prairie caribou live on rocky islands in northern Canada. These caribou's light-colored coats help them blend in with the snow. Woodland caribou live in Canada's taiga. Woodland caribou are the largest kind of caribou. They are always on the move in order to find food and keep safe from predators. Bear and ground caribou are the most common kind of caribou. These caribou live in huge herds and make some of the longest migrations. They live in Alaska and in Canada's Yukon, Northwest, and Nunavut territories. The ones in Alaska are sometimes known as Grant's caribou. All about migration. The place where a herd lives is called its range. Each year, caribou migrate between their summer and winter ranges. Summer ranges are often in the mountains or along the coast of the Arctic Ocean. In the summer, these places have plenty of food for caribou to eat. In the winter, though, they become very cold and snowy. The herds migrate to warmer homes in the fall. In April, caribou start walking to their summer ranges. They cross hundreds of miles, kilometers, of evergreen forests and tundra. By August, the caribou have started to fatten up. They are ready to begin their journey by September. Caribou migration. These migrating caribou are members of the porcupine herd. The herd has about 100,000 members. It is one of the most studied caribou herds. This map shows the places where caribou live. Scientists think that there are around 5 million caribou in the world. These caribou make up more than 50 herds. North America is home to 34 of these herds. This map shows the range of the porcupine herd. In the summer, the herd stays near the places where the calves are born. In the winter, it travels inland. Life in the herd. No one knows exactly how migrating herds find their ways to their summer ranges each year. They move quickly, though. Once they start traveling, caribou can cover up to 50 miles, 80 kilometers a day. The first caribou to start migrating in each herd are the older females. The younger females and calves come next. A few weeks later, the male caribou follow. In the fall, male caribou fight each other. This time is called the rut. The males crash their antlers together, trying to show that they are the strongest. Male caribou fight because they are trying to find mates. Caribou calves. Each year, caribou herds return to the same calving grounds. These are special places where female caribou, called cows, give birth to caribou babies, called calves. The calves are born between May and July. When it is time for a cow to have her baby, she leaves the herd and finds a safe place to have the baby. The cow and calf rejoin the herd a few days later. Caribou stay close to their mothers during their first few months. By fall, they have grown enough to look after themselves. Male caribou, called bulls, generally live for about 7 years. Female caribou can live for as long as 10 years. Food and predators. Caribou are herbivores. This means they eat only plants. Finding plants to eat is hard for migrating caribou since the ground is covered in snow for much of their journey. During spring and summer, caribou may eat Arctic cotton grass, willow leaves, mushrooms, or flower buds, depending on where they are. In the fall and winter, food is harder to find. During these seasons, caribou eat frozen lichen, dried sedges, or small shrubs. Caribou have many natural predators. Wolves, wolverines, and bears are among the animals that hunt caribou. Golden eagles and lynx prey on caribou calves. Caribou and people. People hunt caribou too. In fact, people have been hunting caribou for tens of thousands of years. In Alaska, hunters kill about 22,000 caribou for their meat each year. At times, hunters are not allowed to hunt caribou from certain herds if the population of that herd is getting too small. Caribou meat is an important food for the Inuits and other peoples who live in the Arctic parts of North America. In Europe and Asia, people have raised domesticated reindeer for thousands of years. For example, the native peoples in Asia's Altai Mountains raise reindeer for their milk, meat, and skins. The future for caribou. Today, people are destroying the places where caribou live. We cut down forests, build roads, and drill for oil in places through which caribou herds migrate. Climate change also causes trouble. It causes changes in weather that are a problem for caribou. Sometimes caribou arrive at their summer ranges to find that the plants they generally eat have not yet grown or have already died. Today, people are working to end climate change. We have also set aside some land for Arctic wildlife. With our help, caribou should be around for a long time.
Honey Badgers by Julia J. Quinlan. Meet the honey badger. The honey badger is one of the toughest animals on Earth. Honey badgers might not look that scary at first glance, but they are actually vicious fighters. They are called honey badgers because they like to eat honey. They are also known as rattles. Honey badgers are related to weasels and otters. However, they are much more ferocious than their relatives. Honey badgers have claws they use for fighting and digging. They have sharp teeth. One of the most amazing things about honey badgers is their resistance to snake venom. Snake bites that would kill other animals only put the honey badger to sleep for a little while. Honey badger habitats. Honey badgers are found in many places. They live in the Middle East, India, parts of Central Asia, and most of Africa. These areas cover many habitats. The honey badger can live in arid habitats, or kinds of lands that are quite dry. It is also found in rainforests and many habitats in between. Honey badgers like to live in underground homes called burrows. They use their claws to dig burrows for themselves. Sometimes honey badgers will move into burrows dug by other animals, such as aardvarks. Honey badgers will live in tree trunks or in caves if they cannot make or find burrows. Skunk lookalikes. Honey badgers have black hair covering most of their bodies. They have white stripes that go down their backs from the tops of their heads to their tails. They have similar coloring to skunks. Like skunks, they also have body parts that make them smell really bad. The smell helps drive predators away. Honey badgers are usually about 2 to 2.5 feet, 61 to 76 centimeters long, and 8 to 12 inches, 20 to 30 centimeters tall. They have strong legs and long claws. Honey badgers have loose skin that lets them twist around to get away from predators or to attack them. Nighttime hunters. Honey badgers are not friendly animals. For the most part, they live alone. Honey badgers are nocturnal. That means they are most active at night. Honey badgers will sometimes be awake at dusk and dawn, but are rarely up during daylight. Honey badgers have home ranges or areas in which they live. The home range of a male honey badger can be up to 200 square miles, 518 square kilometers. Females have smaller ranges of about 50 square miles, 130 square kilometers. Honey badgers move around a lot. They do not stay in the same burrow for long. This lets them avoid predators and find more food. Ferocious honey badgers. Honey badgers are fierce fighters. They will attack any animal that threatens them. They fight dangerous snakes, such as cobras, puff adders, vipers, and black mambas. Honey badgers are quick and never give up. They chase other animals up trees, underground, and into the bush. Baby honey badgers. Honey badgers take a break from their solitary lifestyle when it is time to mate, or make babies. In many places, male and female honey badgers mate in September and October. Female honey badgers generally give birth to one baby at a time, but will sometimes have two. Baby honey badgers are usually born in May. The babies are born without any hair. Their hair starts to grow after about 2 weeks. Male honey badgers do not stay with the mother and baby. Honey badgers in captivity have lived as long as 26 years. Scientists are not sure how long honey badgers live in the wild. What do they eat? Though honey badgers are named for their love of honey, they are carnivores. They eat mostly meat. Honey badgers eat just about anything they can catch. They eat snakes, birds, and insects. They also eat small mammals and the young of larger mammals. When a honey badger finds a beehive, it doesn't just eat the honey inside, it also eats the bee larvae. Bees sting honey badgers that attack their hives. The badger's thick skin keeps them from being too badly hurt, though. Honey badgers sometimes follow birds called honey guides to find hives. After the badger breaks the hives open, the birds feast on honey and larvae too. Honey badger predators. Honey badgers may be tough and fearless, but that doesn't mean they do not have predators. Large mammals, such as lions and leopards, sometimes hunt honey badgers. Even honey badgers are no match for these big cats. Smaller animals try to prey on the honey badger, but the honey badger knows how to defend itself. Honey badgers fight back using their teeth and claws. Their thick skin protects them from many bites, and its looseness allows them to wriggle away or reposition themselves to bite their attackers. Honey badgers can also spray attackers, just as skunks can. People and honey badgers. Humans are the honey badger's most dangerous enemies. Many people who live in areas with honey badgers do not like them. That is because honey badgers often go onto farms at night and eat livestock or chickens. Many farmers will kill honey badgers if they see them. Honey farmers especially dislike the honey badger. Honey badgers will destroy beehives, which leaves honey farmers with less honey to sell. Since honey badgers eat bee larvae, the farmers end up with fewer bees to make honey too. Honey farmers set traps for honey badgers. They also poison them. Tough honey badgers. Even though honey badgers are hunted by people and get themselves into a lot of dangerous fights, they are not endangered. It is hard to know exactly how many honey badgers there are because they are found in so many places and live alone most of the time. Honey badgers can fight off most animals. They almost never back down from fights. They get stung by bees and bitten by snakes, but keep eating. These incredibly tough animals are among the world's most ferocious fighters.
Exploring the Moon by Rebecca Olien. The Moon. Earth is the only planet in our solar system that has one moon. The planets Venus and Mercury have no moons at all. Mars has 2 small moons. Its smallest moon is less than 8 miles, 13 kilometers across. Our moon is much larger at 2,160 miles, 3,476 kilometers across. 4 other moons in our solar system are about the same size as Earth's moon. The moon is closer to Earth than any planet or star is. It is about 239,000 miles, 385,000 kilometers from Earth. It does not make its own light. The moon is bright because it reflects sunlight. The moon's beginning. The moon formed about 4.5 billion years ago. Most scientists think the moon was made when an object the size of Mars crashed into Earth. It struck Earth so hard that huge chunks of rock were thrown into space. Together, the object and the rock from Earth formed the Moon. This crash is sometimes called the Big Splat. The Moon was very hot when it first formed. Its rocks were so hot they melted into lava. It took millions of years for the Moon to cool. As it cooled, heavier rock settled beneath lighter rock and produced layers. The Moon's layers. The Moon is made of 3 layers, called the crust, the mantle, and the core. The crust is the outside layer. The crust is covered with a layer of dust and small rocks, called regolith. When the Moon formed, the lighter rock floated up to make the crust. The heavier rock formed the mantle. The mantle is the thickest of the Moon's layers at about 790 miles, 1,270 kilometers thick. The core is the layer at the center of the Moon. It is the hottest part of the Moon, with a temperature of more than 1,832 degrees Fahrenheit, 1,000 degrees Celsius. Craters. A crater is a pit on the Moon's crust made by falling rocks. When the Moon first formed, space was full of moving rocks called asteroids. Many asteroids hit the Moon and dug away land. This left behind craters. The word crater comes from the Greek word crater, which means bowl. The Moon is covered with thousands of craters. Most are the size of small bowls. Others are much larger. The largest crater on the Moon is called the Hertzsprung. It is 369 miles, 594 kilometers across. Many of the Moon's large craters are ringed with tall, rocky walls. Mountains and Maria. The Moon has mountains, just as Earth does. They are called highlands. About 80% of the Moon is covered in highlands. The highlands are bright spots on the Moon that we can see from Earth. Maria are flat places on the Moon. Maria is the Latin word for seas. People used to think the Maria were once filled with water. We now know that the Maria began as large craters. Lava bubbled up from inside the Moon and spilled into the craters. The lava became hard as the Moon cooled, forming the Maria. The moving Moon. The Moon is a satellite. The Moon stays in orbit around Earth because of gravity. Gravity is a force that pulls 2 objects together. It takes a little more than 27 days for the Moon to orbit Earth. We see only one side of the Moon. This is because the Moon spins as it orbits. It takes the Moon the same time to spin as it does to orbit. The side seen from Earth is called the near side. The side facing away from Earth is called the far side. Phases of the Moon. The Moon goes through 8 different phases. A new moon happens when the Moon is between the Sun and Earth. During a new moon, the Moon cannot be seen because no sunlight reflects off the side facing Earth. Each night that follows, a little more of the Moon appears. The Moon looks largest when it is full. It is full when it is on the opposite side of Earth from the Sun. After a full moon, the Moon begins to look smaller each night. It takes about 1 month for the Moon to go through all 8 phases. Lunar eclipse. A lunar eclipse happens when all or part of the Moon becomes dark. During an eclipse, Earth is lined up between the Sun and the Moon. Earth blocks the sunlight, making a shadow that falls on the Moon. In most eclipses, Earth's shadow darkens only part of the Moon. This is a partial eclipse. During a total eclipse, the whole Moon becomes dark and seems to disappear. A total eclipse lasts about 3 hours. During this time, people can watch the Moon slowly darken and then brighten as it passes through Earth's shadow. Going to the Moon. The Soviet Union sent the first rocket to the Moon in 1959. In 1969, America sent Apollo 11. This was the first rocket ever to land on the Moon. Astronauts took pictures and gathered rocks to bring back to Earth. No sign of life was found on the Moon. The sky on the Moon is always black. This is because the Moon has no atmosphere to reflect the sunlight. A total of 70 rockets has been sent to the Moon, and 12 astronauts have walked there. Could we live on the Moon? When astronauts visit the Moon, they need to wear special spacesuits. Even with spacesuits on, astronauts cannot stay there long. This is because the Moon has no atmosphere. Without an atmosphere, there is no air to breathe. The Moon also gets much hotter and colder than Earth. Temperatures on the Moon reach 253 degrees Fahrenheit, 123 degrees Celsius during the day. However, the temperatures can drop down to minus 280 degrees Fahrenheit, minus 173 degrees Celsius at night. Someday it might be possible for you to visit the Moon, but it would be very hard to live there.
Investigating Spiders and Their Webs by Ellen Renee.
Amazing spiders! You have likely seen lots of spiders and spider webs. Have you ever wondered how a spider web got there? Have you ever wanted to know how a spider can drop down from above on a thin thread? If you have, you think like a scientist. Scientists wonder about the world around them. Like detectives, they ask lots of questions. Scientists look for clues, collect facts, and study what they learn. Often they end up with more questions than answers. How would science detectives investigate spiders and their webs? First, they would learn all about spiders. How can you tell it's a spider? There are many kinds of spiders. They live all around the world. Spiders are arachnids. This means that spiders have 8 legs and 2 body parts. Spiders have a hard outer covering too. Their eyes, mouth parts, and legs are on the front part, or the cephalothorax. Their heart and silk spinning organs are in the back part, or the abdomen. Most spiders have 8 eyes. Even with all those eyes, many do not see well. Special hairs on their legs and bodies help them sense their surroundings. Most spiders live only 1 or 2 years. Some big tarantulas live to be 20, though. What is spider silk? All spiders make silk, even if they do not build webs. For their size, silk threads are stronger than steel. They stretch or give more than elastic. Spiders have silk glands in their abdomens. Spiders make liquid silk inside these glands. Different silk glands make different kinds of silk. Hunting spiders have 4 silk glands. Trapping spiders have 7. They use several kinds of silks to build their webs. Silk glands connect to spinnerets, which spin the silk into threads. Liquid silk comes out of openings in the ends of the spinnerets. Scientists are not sure how the liquid silk becomes a solid thread. Different kinds of threads. Spiders make silk for many jobs. They can make strong, thick threads. Spiders use this kind of thread to tie up prey. Strong, thick threads also make the frame for webs and hold hanging spiders. Spiders can also make sticky threads. Sticky threads and webs help catch prey. Stretchy threads keep webs from breaking when insects crash into them. Many spiders make nests out of fine, thin silk. Female spiders place their eggs in a silk sac. To make the walls firm, the spiders crisscross the threads. Can spiders fly? Spiders fly through the air without wings. How do spiders do this? They hitch rides on the wind. This is called ballooning. Baby spiders, called spiderlings, climb up high, stand on tiptoe, and face the wind. They stick their abdomen in the air and make a silk thread. Air catches the thread and lifts the young spiders into the air. Ballooning puts spiderlings in danger. Birds eat them. They may land in places where spiderlings cannot live. Why do they do it then? If they hang around the crowded nest, they are likely to be eaten by a hungry brother or sister. Drag lines. As most spiders move from place to place, they trail long silk threads behind them. These drag lines mark a spider's path. Spiders may use them to retrace their steps. These thick, strong silks are the threads people see most often. Spiders use them to drop down from high places. At spots along the way, spiders stick their drag lines to things to mark their path and to keep them safe if they fall. These spots look like tiny white dots, and they are very hard to see. Drag lines also form the frames of orb webs. What kinds of webs are there? Spiders eat animals. They dine mainly on insects and sometimes on other spiders. Some spiders hunt for bugs on the ground. Others catch their dinner using webs. Spiders use many different kinds of webs to trap insects. Some look like sheets, funnels, or tubes. Many spiders build orb webs to catch dinner. First, they make the frame and spokes. Then they weave a spiral across all the spokes to make a net. Last, they add sticky catching threads. Spiders use touch, not sight, to weave their traps. This is a good thing since most spiders build their webs at night. Do all spiders build webs? You may wonder whether all spiders build webs. The answer is no. All spiders have silk glands, though. All spiders create silk to wrap their eggs, too. However, some spiders hunt for food instead of trapping food in a sticky web. There are many kinds of hunting spiders. Some walk around looking for food. Others lie in wait. Crab spiders sit on leaves and flowers without moving. They stretch out their legs and wait. When yummy butterflies or bees land nearby, these spiders sense the movements and attack. Gotcha! Generally, when a spider moves in for the kill, it catches its prey with the tips of its front legs. Then it pulls the prey to its fangs and bites. The spider's fangs inject venom. The spider wraps the insect in silk threads and starts feeding. Spiders cannot chew. Instead, their fangs put something into their prey that makes its insides liquid. Spiders suck the liquid through a small mouth opening. When they are done, their victims are like empty boxed drinks with all the juice sucked out. Case solved? Have you found out everything you wanted to know about spiders? Chances are you have thought of even more questions. For example, did you know that there are about 30,000 different kinds of spiders? Did you know that scientists have found spiders ballooning out in the middle of the ocean? There is so much to learn about spiders. Have fun trying to answer your questions. Look for answers at the library or on the web. Try to answer your questions by observing or watching closely the spiders that may share your house or backyard with you. You will find that spiders truly are amazing.
Investigating Why Leaves Change Their Color by Ellen Renee. Out of thin air. Have you ever looked up at a tall, leafy tree and wondered, how did it get so big? For a long time, scientists did not know. They thought plants, like animals, had to eat to grow. The scientists guessed that plants ate something in soil. Today we know that plants build themselves, mostly from the air. That is where they get carbon, a building block for life. The carbon plants use comes from carbon dioxide, a gas in the air. Plants turn carbon dioxide and water into food. This is called photosynthesis, and it takes place inside green leaves. Why green leaves, you might ask? What about when leaves change their color? What is photosynthesis? Plants need energy or power to live and grow. They get it from sugar, the energy-rich food they make. Where does the energy stored in sugar come from? That energy comes from the sun. Photosynthesis means putting together by light. Sunlight helps plants put carbon dioxide and water together to make sugars and other carbohydrates. The plant gives off oxygen, the gas we breathe. Plants have to trap sunlight before they can use it, though. How do they do that? They have a powerful green superhero in their leaves. It saves the day, or really daylight. This plant superhero is chlorophyll. Chlorophyll and sunlight. Chlorophyll traps sunlight and helps plants use the energy it holds. People use sunlight's energy too. We need it to keep us warm, and we need it to see. The sun makes its own light. Most things do not. Sunlight looks white to us. It is really made up of waves of many different colors, though. An object's color depends on the light waves it reflects or sends back to your eyes. White objects reflect all colors of light. Black objects take in or absorb all colors of light. Chlorophyll absorbs most sunlight. It reflects green waves, though, so it looks green. What makes leaf colors? Pigments color living things. They absorb and reflect different waves of light, so an apple looks red, and a sunflower looks yellow. 3 groups of pigments color leaves. Chlorophyll colors leaves green. Carotenoids color them mostly yellow and orange. Both groups are found in leaves all through the growing season. Anthocyanins are made in fall. They color leaves red and purple. Pigments do more than color leaves. They help leaves carry on life processes. The carotenoids help out with photosynthesis. They catch light and pass it to chlorophyll. Sun catchers. Leaves come in different shapes and sizes. Some leaves grow as long as railroad cars. Others fit on the head of a pin. All carry on photosynthesis. The way they are built helps them do this job. Most leaves have 2 parts, a blade and a stalk. The thin stalk fixes it to the plant. The wider blade helps leaves catch sunlight and take in carbon dioxide. Gases move in and out of leaves through tiny openings or pores. A thin, waxy coating covers most leaves. It keeps them safe and keeps them from drying out. How do plants move food around? Roots take in water and minerals from soil. Leaves make food and other matter. How do things move around inside plants? They move through a system of tubes. One kind of tube moves water and minerals up from roots to leaves. Another kind of tube moves food from the leaves to where it is needed. Leaves use some of the sugars they make in photosynthesis. Extra food goes to other plant parts, like stems and roots, where it is used or stored. The two kinds of tubes are the veins you see on leaves. Hidden color. During the growing season, photosynthesis goes on full blast. Leaves make a lot of chlorophyll. They need a steady supply. Sunlight breaks chlorophyll down. This happens in the same way that sunlight fades colored paper or cloth over time. Leaves also make carotenoids to help chlorophyll. Why are leaves green if yellow and orange pigments are present? Look at bananas for clues. As bananas ripen, they turn from green to yellow. Yellow color is there all along. Chlorophyll hides it. When chlorophyll breaks down, yellow color shows through. What do you think will happen when photosynthesis stops in leaves? Shutting down. In spring and summer, plants make so much chlorophyll that it masks the other colors. In fall, it gets colder outside. There are fewer hours of daylight. These changes say winter is coming. Plants start to close up shop. The connection between the plant and the leaves closes. In the leaf blades, photosynthesis slows, then stops. The broken down chlorophyll is not replaced. Carotenoids do not break down as fast as chlorophyll. They hang around coloring leaves yellow and orange. During this time, plants also begin to make anthocyanins. Nature's big show. Do you live where seasons change? Then you can observe nature's big show. All deciduous plants have a part to play. The real stars, though, are the trees that shed their leafy costumes before winter arrives. In yellows and oranges are hickory, elm, cottonwood, black walnut, ash, larch, and others. Not to be outdone are dogwoods, alders, and some oaks in showy shades of red. Sugar maples turn pale yellow, bright orange, and red. What players will you see on fall's stage? It depends on where you live. Leaf detectives. Fall's brightest and deepest reds come from anthocyanins, which do not form until fall. Leaves start shutting down in fall, though. Why do they use their energy to make new pigments? Scientists have tried to explain this mystery. They asked, how will this matter help the plant? Some think it keeps bugs away. Others think it acts like a sunscreen so the plant can get food from the leaves for longer. Do you have any questions about leaves and their colors? Try to find out the answers. Start by watching the leaves as they change. Enjoy the show.
Investigating Why Animals Shed Their Skin by Ellen Renee.
Your epidermis is showing. Did you know your epidermis is showing? Do not worry. It is your skin. It is strong and smooth, and it stretches. It is thinnest on your eyelids and thickest on your feet. Like your heart, skin is an organ. It grows as you grow. All animals have skin covering their bodies. Without it, they would dry out. Skin also helps keep bad things out of the body. Warm-blooded animals need skin to keep their bodies from getting too hot or cold. Do you think all animals have skin like yours? Is all skin alike? Not all skin is alike. Animals without backbones have very different skin from animals with backbones. Skin may look different from one part of an animal's body to another, too. Many things come from skin, such as hair, nails, claws, feathers, scales, and horns. All animals shed or get rid of skin. Some lose skin in pieces. Others lose it all at once. Some shed skin at certain times in their lives. Others never stop. Many animals also shed some of the things that grow from skin. If you wonder why animals shed, you think like a scientist. How do spiders and insects grow? Spiders and insects do not have backbones. Their skin is like a hard shell that keeps them safe and gives them shape. It is called an exoskeleton. It does not get bigger when the animal does. How do spiders and insects grow then? They must molt or shed their skin. Before they do, they make new skin underneath their hard shells. It is folded and squished inside. When spiders and insects molt, their old shell splits or breaks open. They wiggle out wearing soft, wrinkly new skin. Soon the new skin hardens. With each molt, they get bigger. A yummy snack. Frogs drink and breathe through their skin. They have mouths, but they do not swallow water like you do. They have lungs, but they need extra oxygen. Frogs get it through their skin, mainly when they are underwater. If a frog's skin dries out, it will die. Special parts in frog skin make mucus to keep it wet. Many frogs shed their skin weekly. They twist, turn, bend, and stretch to loosen old skin. Then they pull it off and eat it. Frogs get water and nutrients from their old skin. All at once. Snakes shed their skin in one piece. It splits on their heads. To help, they rub their heads against something hard. Then they move between objects that trap and hold the skin. As they slide away, they leave their old skin behind. Before snakes lose their old skin, they grow new skin underneath. A milky liquid fills the space between the two skins and helps them come apart. This clouds the snake's eyes, which puts it in danger from enemies. Shedding helps the snake too, though. It gets rid of worn-out scales and bugs on the snake's skin. Other scaly shedders. Not all reptiles shed like snakes. Lizards lose their skin in patches. Their skin may look torn up for a few days. The shedding generally starts with a split on the animal's back. The lizard's new skin is already waiting underneath. Turtles shed their skin too. It flakes off their head, neck, and legs. Most turtles have a hard, bony shell that is covered by hard plates. Some turtles, like the common painted turtle, shed the top layer or part of these plates. When the common painted turtle finishes shedding, the colors on its shell are brighter. Do birds shed? Do you wonder if birds shed their skin? The answer is yes. Bird skin is thin and stretchy. Birds fit loosely inside their skin. It gives them freedom to move during flight. Birds shed skin all the time. It helps get rid of bugs. Feathers grow from bird skin. They set birds apart from all other animals. At certain times throughout their lives, birds molt. It replaces worn-out and broken feathers with new ones. Molting birds cannot fly or swim the way they normally do. Oh dear! Mammals with split hooves have horns. Like feathers and hair, horns come from skin. Cattle, antelope, sheep, goats, and other horned animals shed skin and hair. They keep their horns, which grow throughout their lives. Other hoofed mammals, such as male deer, elks, and moose, have antlers. Antlers grow from bony nubs on their heads. Antlers are covered with fuzzy skin called velvet. Once the antlers stop growing, the velvet is shed. Males use antlers to get and fight for mates. After the breeding season, males shed their antlers. They will grow new ones next year. Furry friends. If you have a dog or cat, then you already know they shed. In fact, they shed a lot. You can see their hair all over the place. Hair comes from skin. It is one of the things that sets mammals such as dogs, cats, deer, and people apart from other animals. Hair helps keep mammals warm. Mammals shed skin too. The dead skin that flakes off of your furry pet is called dander. Dander does not bother some people, but it makes other people sick. You cannot stop your pets from shedding. It is a natural part of life. A new you. Animals leave bits of themselves all over the place. Some shed to grow. Others shed to renew skin or replace worn-out skin parts. You shed too. In fact, you shed about 9 pounds, 4 kilograms of skin a year. Every minute, about 30,000 to 40,000 dead skin cells flake off your body. They fall on your clothes, bed, desk, and floor. You also lose about 50 to 100 hairs each day. Do not worry, though. Your body makes hair and skin all the time. In fact, you replace all your skin about every month. Talk about a new you.
Who lives on the cold, icy tundra? By Rachel Lynette.
What is the tundra? Unless you live very far south, very far north, or high on a mountain, You have likely never been to the tundra. Very few people live on the tundra because it is a harsh, cold environment. There are two kinds of tundra. One kind is called alpine tundra. Alpine tundra is the land above the tree line on mountains. This land is at high altitudes, where the air is cold and trees cannot grow. Another kind of tundra is the Arctic tundra. The Arctic tundra runs from the North Pole through parts of Alaska, northern Canada, and Russia. Both kinds of tundra have some things in common. Some of these common features are low temperatures, no trees, poor nutrients, short growing seasons, and fewer kinds of plants and animals than warmer places. Seasons on the tundra. It is so cold on the tundra that much of the ground stays frozen all year long. The average temperature in the Arctic tundra is minus 18 degrees Fahrenheit, minus 28 degrees Celsius. But it can get as cold as minus 94 degrees Fahrenheit, minus 70 degrees Celsius. In the summer, it gets warm enough for the top of the soil to melt. However, because of the permafrost beneath this soil, trees cannot grow. Only low-growing plants with short roots, such as bushes, wildflowers, grasses, mosses, and lichens, can grow on the tundra. When the top part of the soil melts, the ground can be very wet. Marshes, lakes, bogs, and streams can cover the landscape. This brings lots of bugs and birds to the Arctic tundra during the summer months. Arctic animals. Even though it is very cold and windy on the tundra, some animals can live there. However, most of these animals do not stay on the tundra all year. Instead, they migrate to places where it is warmer during the coldest winter months. Animals that live in the Arctic have adapted to the harsh weather. Mammals have thick layers of fur to keep them warm. Caribou have hollow hair that holds warm air near their bodies. Musk oxen have soft, woolly fur underneath their heavy outside coats. Small mammals like Arctic hares, lemmings, and voles burrow under the snow to stay warm. The Arctic fox. Arctic foxes have thick coats that have two jobs. Their coats keep them warm in temperatures as low as minus 58 degrees Fahrenheit, minus 50 degrees Celsius. They even have fur on the bottoms of their paws to keep their feet warm. Their coats also help them blend in. The coat is white in winter to blend in with the snow. In summer, the coat becomes gray or brown to match the landscape. Arctic foxes eat lemmings, hares, voles, and other small animals. Arctic foxes will also follow a polar bear and eat what the polar bear leaves behind. However, the foxes must be careful, or they will become the polar bear's food, too. Antarctic animals. Antarctica is even colder than the Arctic. Almost all of it is covered in ice. No land mammals live in Antarctica. However, 6 species of seals live in the sea around Antarctica. Although they spend most of their time in the water, seals must come on land to breed or make babies. Seals have a thick layer of fat to help them stay warm in the icy waters and on land. When most people think of Antarctic animals, they likely think of penguins. There are 17 species of penguins, but only 4 kinds breed on Antarctica. These are the Adelie, the Emperor, the Chinstrap, and the Gentoo penguins. Powerful swimming penguins. Penguins live in large groups called rookeries. On land, penguins often huddle together to stay warm. Penguins spend most of their time in the water. Some kinds spend as much as 75% of their life at sea. The biggest penguins in Antarctica are emperor penguins. They are about 45 inches, 114 centimeters tall. Powerful and fast in the water, they can dive down more than 1,800 feet, 550 meters. They can also hold their breath for over 20 minutes. One of the most common penguins in Antarctica is the Adelie penguin. There are around 2.5 million pairs. Adelie penguins are about 27.5 inches, 70 centimeters tall. Coming and going. Many animals come to the tundra during the spring and summer and migrate to warmer places for the cold winter. Caribou travel in large herds. There may be more than 10,000 animals in a single herd. A herd of caribou may migrate over 500 miles, 800 kilometers, from the forests in the south to the tundra. They come to the tundra to eat lichen. They use their hooves to cut through ice and snow to find this yummy dinner. Many birds migrate to the tundra in the warmer months, when the melting ice makes bogs. These are an excellent home for water birds like ducks, geese, and sandpipers. These birds stay a few months to breed and then fly south, sometimes for thousands of miles, kilometers. Alpine animals. The alpine tundra is home to many grazing animals, such as alpacas, llamas, yaks, and elks. All of these animals have thick coats to keep them warm. Some grazing animals, such as mountain goats and blue sheep, can climb steep, rocky cliffs. Alpine predators such as wolves, snow leopards, and mountain lions eat these grazing animals. Many rodents and other small animals also make their homes on the alpine tundra. Marmots, snowshoe hares, ground squirrels, and voles live in burrows. They are always on the lookout for predators like foxes, weasels, and eagles. Busy pikas. Pikas are small mammals related to rabbits. Pikas eat grasses, small branches, moss, and lichen. They make their burrows in rocky areas of the alpine tundra. During the summer, pikas gather grasses from nearby meadows. They lay the grasses out on rocks to dry in the summer sun. They then line their burrows with this hay to keep them warm in the winter months. Sometimes pikas will try to steal hay from other pikas. This causes fighting. Fighting pikas need to be careful though. Plenty of hungry alpine animals such as ferrets and large birds are always on the lookout for easy food. An icy life. Life on the tundra is not easy. Even animals that have adapted to the weather may not live through the winter. However, if an animal dies, it is not wasted. It becomes much needed food for other animals. Animals that are strong enough to make it to summer are rewarded. For a few months, there is plenty of food and the chance to find a mate and breed. Then the cycle of life on the tundra continues.
How Chocolate is Made, From Natural Resource to Finished Product, by Carrie O'Donnell. Chocolate. When it's time for dessert, what's the first thing you think of? For many people, the answer is chocolate. We eat chocolate candy and cake. We drink hot chocolate. We put chocolate chips in our cookies and pour chocolate topping over our chocolate ice cream. Chocolate is one of the world's favorite foods. However, not many people know where chocolate comes from. Did you know chocolate comes from the seeds of a special fruit? The seeds go through a lot of steps to become the chocolate we know and love. Let's find out how chocolate makes its way from a fruit on a tree to the chocolate treats we eat. Chocolate's long history. Chocolate's history goes back at least 2,000 years. The Maya and the Aztecs used seeds from the fruit of the cacao tree to make a bitter drink. First, they dried the seeds, or beans, in the sun. Then they cooked the beans in a pan over a fire. Next, they crushed the beans and mixed them with special hot peppers, vanilla, and other things to make a paste. Last, they added water to the mixture to make a liquid they could drink. They believed the drink made them strong. The Maya and the Aztecs considered cacao beans to be very valuable. The Aztecs actually used cacao beans as money. When Spanish explorer Hernán Cortés came to Mexico in 1519, he saw that the Aztecs valued cacao beans as much as they valued gold. Stories say the Aztec king Montezuma drank 50 cups of chocolate every day. Cortés took some beans with him when he returned to Spain in 1528. Soon people in Spain were making the drink for themselves. They added sugar or honey to make the bitter drink sweet. The news about chocolate spread across Europe and finally reached the American colonies. North America's first chocolate factory opened in 1765. How chocolate begins. Just like the chocolate of the Maya and the Aztecs, our chocolate begins with cacao trees, which grow in tropical areas around the world. The cacao tree's fruit grows from its trunk and branches, and is an important natural resource in these parts of the world. First, the fruit is removed from the tree with a sharp blade. Then the fruit is cut open. Next, the seeds or beans inside are scooped out, along with a juicy pulp. There are usually between 20 and 60 beans inside each fruit. The beans and pulp are placed outside in piles for about a week. During this time, the shells of the beans get harder and darker. After about a week, the beans can be separated from the pulp and dried in the sun. When the beans are done drying, they're packed in bags and sent to chocolate factories around the world. Once the dried beans reach the factory, they're cleaned. Then they're roasted or baked to loosen their shells. As the beans roast, they give off a rich chocolate smell. Next, the shells are removed, leaving the insides of the beans called nibs. These nibs are what all forms of chocolate we eat are made from. Liquid chocolate. In the factory, the nibs are ground up. Heavy machines then crush the nibs, pushing cocoa butter out of them. The cocoa butter and nibs are heated to make a smooth chocolate liquid. Chocolate products are made from this chocolate liquid. What happens next depends on what kind of chocolate is being made. When the chocolate liquid hardens, it makes the bitter chocolate used in baking and candy making. Have you ever seen a bar of baking chocolate? It might look like a chocolate candy bar, but take one bite and you can tell the difference. Baking chocolate has no added sugar, so it doesn't taste good until it's mixed with other ingredients. All kinds of chocolate. Some chocolate is made into cocoa powder. Huge machines press some of the cocoa butter out of the chocolate liquid, turning the liquid into cakes of solid chocolate. Machines then grind the cakes into cocoa powder. Can you think of some ways we use cocoa powder? It's mixed with sugar and milk or water to make hot chocolate. It's also used for chocolate flavor in baked goods and ice cream. Heated chocolate liquid or cocoa powder can be mixed with other ingredients. This is what makes the different kinds of chocolate we love to eat. Have you ever had milk chocolate? It's the best-selling kind of chocolate in the world. To make it, chocolate liquid or cocoa powder is mixed with milk, sugar, and extra cocoa butter. Sometimes vanilla is added. It's then passed through large rollers to make a thick paste. More machines then mix and heat the paste until it's smooth. The longer the paste is mixed, the better it tastes. Dark chocolate is made in much the same way, but no milk is added to it. White chocolate is made without chocolate liquid. It gets its flavor from cocoa butter. The final steps. After the chocolate paste has been mixed, it's heated again. Then it's cooled slowly, which keeps the chocolate smooth. Other ingredients, such as nuts, can be added during this step or added later when the paste is poured into molds. The molds can be many shapes and sizes. They can be used to make small candy bars or huge blocks of chocolate. Some molds are even shaped like animals or people. When the chocolate paste cools inside the molds, it becomes solid. It's now ready to be wrapped, packed, and shipped out. Soon, many people will be enjoying the tasty chocolate treats. In this book, we've learned how the chocolate we eat makes its way to us all the way from the seeds of the cacao tree. Now let's learn how we can make our own special chocolate treats right at home. Be sure to have an adult help you as you follow the steps below. So Many Maps. Reading Different Kinds of Maps by Catherine Ruzinek. Maps show us the way. Travelers have long used maps to find their way to and around unfamiliar places. Many years ago, explorers created maps to show others what newly discovered places looked like. Today, we still look at these maps to learn about the past. We use modern maps for many purposes. Maps show us what places look like. They also show us directions, distances, bodies of water, and different types of land. Some show how much rain an area gets. Others show the population of a state or city. Our world would be very different without maps to help us. Mapping our world. Earth is a big place. Maps help us make sense of our world, even places we've never visited. In order to use maps, we need to understand their basic elements or features. A compass rose shows the cardinal directions: north, south, east, west. This helps map readers understand which direction a person needs to travel to get from one place to another. Maps often have keys that explain the symbols found on them. Some maps have a scale to help figure out the actual distance between two places. Without an understanding of these basic parts, using a map would be hard. A map may have a grid to make it easier to find a location. A grid is made up of vertical and horizontal lines that divide a map into equal-sized squares. Along the top or bottom, the columns or spaces between the vertical lines are labeled with numbers. Along the left or right, the rows or spaces between horizontal lines are labeled with letters. The areas where these spaces cross form squares. Each square has a name made up of a letter and a number, such as C3 or H7. To use a map with a grid, first find the name of the place you are looking for in the index. Then use the letter and number next to the name to find the square on the map where the place is located. Some maps show a different kind of grid covering Earth's surface. Lines of latitude are numbered horizontal lines north and south of the equator. They form circles that get smaller the closer they get to Earth's poles. Lines of longitude are numbered vertical lines. They form circles around Earth's surface that are all the same size and that cross at the poles. Lines of latitude and longitude form a grid that can be used to find a location anywhere on Earth. Many maps show lines of latitude and longitude. Sometimes the spaces between lines of latitude and longitude are broken down into more lines that are closer together. This makes it even easier to find places on a map. Where in the world are we? Perhaps the two most common uses for maps are showing what places look like and figuring out how to get to them. European explorers made hand-drawn maps of places where no other Europeans had gone before. These maps showed coastlines, mountains, lakes, and rivers. Later maps showed forts and settlements. Modern maps show these things too. However, they also show towns and cities, as well as the roads and highways that connect them. This helps travelers avoid getting lost. When traveling, it helps to know what the land is like where you're going. Many maps show landforms such as mountains, hills, deserts, and islands. Bodies of water such as rivers and lakes are also landforms. Knowing where landforms are can help a traveler plan a trip. Some travelers like to avoid landforms such as lakes that would make their trip longer. Other travelers like to plan a trip to a landform, such as a skier traveling to a mountain. Some landform maps, like this map of West Virginia, use colors to show differences in elevation. The key will help you understand which areas are higher than others. Look at all the people. Not all maps are meant to help people locate a place or plan a trip. Maps sometimes show data about the people living in an area. Population maps often use different colors and a key to show the number of people per square mile or square kilometer. A population map may give additional facts to help readers better understand the people living in an area. For example, some list the major nationalities that occupy an area. A population map may be used to show data for things other than people. For example, you may see a map that shows where different kinds of birds live. Doing business. Economic maps tell readers more about the people and communities in an area. They often show data about the businesses or natural resources in a state or country. Economic maps may or may not include cities, towns, and highways. They can be helpful when we want to learn more about an area other than what it looks like or where its cities and roads are located. You might use a map like this when writing a report or planning a speech. Small symbols on an economic map, called icons, stand for different resources in an area. For example, the map on page 27 uses an apple to show where fruit is grown. So many maps. We've looked at just a few of the many kinds of maps. Maps have so many uses. Can you think of other kinds of maps and how they are used?
Hydropower. Making a Splash by Amy S. Hansen.
Energy from moving water. A river rushes under a bridge. Ocean waves swell. The outgoing tide pulls water back from the